Right now, as you sit comfortably in your room, the walls of reality are silently closing in on you, and there is absolutely nothing you can do to stop it. For thousands of years, humans looked up at the stars and believed they were eternal, static, and forever within our reach, waiting for us to eventually explore them. But that sense of permanence was a lie, because the universe is not a static painting. It is a violent, expanding cage that is actively deleting history from our view. At the very edge of the observable universe, a boundary exists where light itself creates a prison wall that no telescope, no matter how powerful, will ever be able to breach. We used to believe this horizon was just a limit of our technology, a temporary blindness that better machines would eventually cure as we advanced our understanding of physics. However, a terrifying discovery lurking in the data of the James Webb Space Telescope suggests that this boundary is not just a limit of sight, but a limit of reality. Something sitting at the absolute end of space is pulling galaxies away from us faster than the speed of light, effectively erasing them from existence before we can ever see them. Astronomers call this phenomenon the cosmic event horizon, but a darker interpretation of the data suggests it acts more like a cosmic mouth devouring the light of creation. Every single second that passes, thousands of stars cross this invisible threshold and vanish from our observable sky forever, lost to a void we can never map or understand. We are being isolated in a shrinking bubble of light, and recent calculations indicate that the darkness is winning the war for the future of our universe. The implications of this isolation are existential horror on a scale the human mind struggles to comprehend, turning our galaxy into a lonely raft in an infinite dying ocean. But the mystery deepens when we analyze the movement of the galaxies that are still close enough for us to observe and measure with our instruments. They are not just drifting randomly through the void. They are flowing like a river toward a specific point in the sky that we cannot see. Something massive, something invisible and impossibly heavy, is lurking just beyond the edge of our vision, dragging our entire local universe toward a catastrophic rendezvous. Scientists refer to this inexplicable movement as the dark flow, a phenomenon that defies the standard model of cosmology and suggests we are part of a much larger, unseen structure. Imagine a force so powerful that it can grab clusters of millions of galaxies and pull them across the universe at speeds that defy gravitational logic. The data implies that whatever is pulling us is not made of matter as we know it, but is perhaps a defect in the fabric of space-time itself. We are drifting towards a cosmic drain, and the scary part is that we have absolutely no way of knowing what lies at the bottom of it. This discovery forces us to confront the possibility that our universe is not the safe, uniform bubble we were taught about in school, but a chaotic fragment of something worse. The expansion of the universe was supposed to be smooth, a gentle stretching of space that pushed everything apart equally in all directions, like a rising loaf of bread. Instead, we find lopsided anomalies, cold spots, and vast regions of emptiness that suggest the machinery of the cosmos is broken or malfunctioning in terrifying ways. One such anomaly is the Great Attractor, a gravity well that held our fascination for decades, but the dark flow hints at something thousands of times larger behind it. We are like ants on a leaf flowing down a stream, unaware of the waterfall approaching, only able to sense the water moving faster beneath our feet. James Webb has looked into the abyss and found galaxies that are too bright, too massive, and too old to exist according to our current understanding of physics. These impossible objects suggest that the timeline of the universe is wrong, or worse, that time itself does not function the way we think it does at the edge. If the foundation of our timeline is flawed, then every prediction we have made about the end of the world is likely nothing more than a comforting fairy tale. The silence of the universe is not peaceful. It is the silence of a graveyard where the tombstones are moving away from us faster than we can read them. We are witnessing the slow suffocation of the night sky, a process that will eventually leave our descendants staring into a void devoid of any other galaxies. The cosmic horizon is the ultimate censor, a barrier that prevents information from reaching us, hiding the true nature of the multiverse or the nothingness beyond. What if the expansion isn't just space stretching, but space being pulled apart by a vacuum decay event that has already started somewhere we cannot see? A bubble of true vacuum could be expanding at the speed of light, rewriting the laws of physics and deleting existence, and we would never see it coming. The discovery at the end of space is that stability is an illusion, and the forces holding your atoms together are balanced on a knife's edge. Cosmologists call this the Big Rip scenario, where the phantom energy driving the expansion becomes so strong it eventually tears apart stars, planets, and finally, molecules. But the dark flow suggests a directionality to our doom, a specific destination that the universe is forcing us to travel toward against our will. We are analyzing light that has traveled for 13 billion years, only to realize that the message it carries is a warning we are too late to understand. The structures we see at the edge of space are gigantic, defying the cosmological principle that says the universe should look the same everywhere. We have found a cold spot in the cosmic microwave background, a massive bruise on the sky that might be the fingerprint of a collision with another universe. If we are bumping into another reality, the discovery at the end of space isn't just emptiness, but an encroaching alien physics that could destroy ours. This is the cosmic horror of our time. The realization that we are not observers in a laboratory but specimens in a volatile and decaying jar. The paradox of the Fermi sky asks where everyone is. But the answer might be that they were all pulled over the horizon before they could say hello. We might be the last survivors in a region of space that is rapidly being depopulated by the relentless acceleration of dark energy. Every calculation we run on the mass of the universe comes back with missing numbers, pointing to a vast, invisible bulk hiding just out of sight. This missing mass is not just dark matter. It is the ghost of a universe that is interacting with us while remaining completely untouchable. The edge of space is not a physical wall, but a temporal one, marking the point where the past is disconnected from the present forever. We are racing toward a future where the sky goes black, and the discovery sitting at the end of space confirms that this darkness is inevitable. But there is one final, terrifying possibility that the data allows, that the universe is not expanding into nothing, but expanding into something else. If we are expanding into a larger medium, then the end of space is actually a membrane, a surface that we are about to rupture. Breaking that membrane could flood our reality with energy states that would incinerate the cosmos instantly, resetting the clock to zero. The silence from the stars is not empty. It is pregnant with the threat of a discovery that we are rapidly approaching but cannot see. To understand what is waiting for us at the end of the universe, we must first accept that our map of reality is fundamentally wrong. To understand the magnitude of the catastrophe facing our understanding of reality, we must first look at the foundation we built that is now crumbling beneath our feet. For decades, the standard model of cosmology was our Bible, a rigid mathematical framework that described a universe born in a hot, dense state and expanding outward with predictable, clockwork precision. We believed we had solved the puzzle of existence, measuring the density of matter, the influence of gravity, and the acceleration of dark energy to within a fraction of a percentage point. We built our entire concept of history, from the first second of the Big Bang to the eventual heat death of the cosmos, on these numbers. But the discovery at the end of space has revealed that our confidence was nothing more than arrogance. The map we drew of the universe does not match the territory we are actually traversing, and the discrepancy is not a margin of error. It is a gaping wound in physics itself. The crisis begins with a single, simple number that refuses to sit still: the Hubble constant, the rate at which the universe is expanding. When we look at the oldest light in the universe, the cosmic microwave background radiation left over from the Big Bang, our best satellites tell us the universe is expanding at 67 kilometers per second per megaparsec. This measurement is clean, precise, and backed by the fundamental laws of physics as we understand them. It tells us exactly how old the universe is and how it should behave. But when we look at the universe today, using the light of nearby exploding stars and pulsating galaxies to measure the expansion directly, we get a completely different number: 73 kilometers per second per megaparsec. The universe is moving 9% faster than it should be. It is as if you measured a child's height and found them to be 3 feet tall, but when you looked at their shadow, it belonged to a giant. For years, astronomers tried to bargain with this data, assuming that one of the measurements was flawed, a victim of dirty lenses or cosmic dust obscuring the truth. They hoped that as our telescopes got better, the two numbers would converge, saving the standard model from annihilation. But the James Webb Space Telescope, the most advanced eye humanity has ever opened, looked deeper and clearer than anything before it, and it did not fix the problem. It made it significantly worse. Webb confirmed the distance to these stars with absolute, undeniable precision, removing any hope that this was human error. The tension is real. The universe is expanding at two different speeds simultaneously, a physical impossibility that suggests we are missing a fundamental component of reality, or that the laws of physics themselves are changing as the universe ages. This is not just a debate about numbers. It is a revelation that the universe is broken. If the expansion rate is truly accelerating faster than the remnant heat of the Big Bang predicts, it implies the existence of early dark energy, a phantom force that kicked the universe into overdrive billions of years ago and then vanished without a trace. It suggests that the cosmos is not a smooth, uniform machine, but a volatile engine prone to sudden, violent shifts in gear that we cannot predict. We are attempting to forecast the future of a vehicle that is accelerating out of control, while realize the speedometer on our dashboard is disconnected from the wheels. If the universe is younger and faster than we thought, then our calculations for when the lights go out are wrong, and the end may be approaching much sooner than the tranquil fade to black we were promised. But there is a darker theory gaining traction, one that explains the discrepancy not by adding new particles, but by changing our place in the cosmos entirely. What if the reason the universe appears to be expanding faster around us is that we are living inside a colossal cosmic trap? This is the KBC void hypothesis, the terrifying idea that our Milky Way galaxy, along with thousands of our neighbors, is trapped inside a bubble of emptiness 2 billion light-years wide. Imagine a vast region of space that is significantly less dense than the rest of the universe, a cosmic desert where matter is scarce and gravity is weak. If we are living in a relatively empty bubble, matter from the denser regions outside would be pulling us outward, creating the illusion of a faster expansion. We would be like a boat in the center of a whirlpool, misinterpreting the rushing water as the flow of the entire ocean. If the KBC void exists, it violates the cosmological principle, the assumption that the universe looks roughly the same no matter where you are. To accept this theory is to accept that we are special, that we occupy a unique, anomalous patch of spacetime that is distorting our view of everything. It means that for our entire history as a species, we have been studying the universe from inside a funhouse mirror, deriving laws of physics from a warped reflection. We are sitting in a local hole in the fabric of the cosmos, a region nearly devoid of the gravitational anchors that hold the rest of the universe together. This void is not just empty space. It is a physical structure, a shell of density that is actively pulling us towards its edges, accelerating our drift into the great unknown. This acceleration brings us back to the horror of the event horizon. If we are in a local void that is expanding faster than the cosmic average, then the observable universe is shrinking for us faster than for anyone else. We are being isolated at an accelerated rate. The galaxies on the edge of our vision are not just moving away, they are fleeing. The light they emit is being stretched so thin by the expansion of our local bubble that it shifts into the infrared, then into radio waves, and finally into silence. We are living in a quarantine zone. The discovery at the end of space might simply be the realization that we are cut off from the main body of the multiverse, drifting in a bubble of ignorance that is rapidly becoming a coffin. However, the void does not explain everything. Even if we account for the local bubble, there is still a massive, unexplained motion pulling us and everything around us towards a specific point in the southern sky. This is the dark flow, and it is the most unsettling anomaly in modern astrophysics. While the expansion of the universe should be pushing things apart, galaxy clusters millions of light-years across are streaming together like a school of fish caught in a current. They are moving at speeds of over 2 million miles per hour towards a region beyond the Centaurus constellation. This movement is coherent, massive, and completely inexplicable by the distribution of matter we can see. Whatever is pulling us is not in our observable universe. It is sitting just beyond the horizon, tugging on the threads of our reality. Theories about what causes the dark flow range from the massive to the metaphysical. Some scientists propose the Great Attractor, a gravity anomaly we have known about for years, but calculations show it is nowhere near massive enough to generate this kind of velocity across such vast distances. Behind the Great Attractor lies the Shapley supercluster, a monster of gravity, but even that is insufficient to explain the speed of the flow. The data suggests that the source of the pull is a structure of matter so colossal that it dwarfs anything within our visible cosmos, a titan of gravity that exists outside the sphere of light we are allowed to see. We are feeling the gravitational ghost of a monster that is hiding in the dark, reeling us in with an invisible line. The most terrifying interpretation of the dark flow is that it is the result of a collision with another universe. According to multiverse theory, our bubble of reality might be just one of many, floating in a higher dimensional foam. If our bubble bumped into another one billions of years ago, the gravitational bruise from that impact would look exactly like what we see: a massive, directional pull and a cold spot in the cosmic microwave background. We might be leaking gravity into a neighbor. Or worse, they might be stealing ours. This neighbor could be a universe with completely different laws of physics, a region where matter cannot exist or where time runs backward. If the walls between realities are touching, the end of space is not a vacuum, but a collision zone. This concept aligns disturbingly well with the cold spot, a massive region of the sky in the constellation Eridanus that is significantly colder than the rest of the universe. Standard cosmology says this spot should not exist. The temperature of the early universe should be uniform. Yet, there it is. A supervoid 1.8 billion light-years across, a hole in the heat of creation. It is a scar on the face of the universe. Some physicists argue this is the imprint of a parallel universe pressing against ours, a cosmic kiss of death that drained the energy from that region. If this is true, the discovery at the end of space is that we are not alone in the multiverse, and our neighbors are crowding us out. The implications of the cold spot and the dark flow converge on a single, chilling realization. The universe has a geography we cannot see. We tend to think of space as isotropic, the same in every direction. But these anomalies suggest an axis of evil, a preferred direction in the cosmos that aligns with our solar system in a way that defies statistical probability. The entire universe seems to be oriented around a specific axis, a spine of gravity and temperature that creates a up and down in a place that should have neither. This alignment is so precise and so unlikely that some scientists have jokingly and nervously suggested it looks like a glitch in a simulation, a seam where the texture map of the universe was poorly stitched together. If we entertain the simulation hypothesis even for a moment, the anomalies at the edge of space take on a digital horror. The expansion rate discrepancy, the pixel-like limit of the Planck length, the maximum speed of light acting as a rendering limit, it all points to a system reaching its processing capacity. The end of space might literally be the edge of the hard drive. The dark flow could be the result of data being deleted or archived. We look at the stars and see wonder. A sufficiently advanced observer might look at the same data and see a system crash in slow motion. The breakdown of physics at the horizon is not a mystery of nature, but an error code. Moving back to the physical reality, the James Webb telescope has found galaxies that break the rules of time. These universe breakers are massive galaxies that existed a mere 500 million years after the Big Bang. According to our models, the universe at that age should have been a chaotic soup of gas and small protostars, incapable of forming structured, massive galaxies. Yet there they are, fully formed, red, and ancient, sitting at the dawn of time as if they had been there forever. This suggests that the universe started forming stars and structures almost immediately, or that the universe is far older than 13.8 billion years. If the universe is older, then the dark energy tearing us apart has been active longer than we thought, and the structural integrity of space is weaker than we calculated. These ancient galaxies host supermassive black holes that are also impossibly large. We see black holes millions of times the mass of the Sun existing when the universe was an infant. There simply wasn't enough time for them to eat enough matter to grow that big. Unless they didn't grow. Unless they were born that way. This leads to the theory of primordial black holes. Black holes that formed in the first fraction of a second after the Big Bang, created not by dying stars but by the sheer density of the universe collapsing on itself. If the early universe was filled with these monsters, then the dark matter we can't see might actually be billions of ancient black holes swarming around us, invisible remnants of a violent birth. The existence of primordial black holes changes the destiny of the universe from a slow fade to a violent evaporation. If the dark matter holding our galaxy together is made of black holes, then slowly, over eons, they will consume the normal matter. Our future isn't just darkness. It is being eaten from the inside out by the invisible skeleton of our own galaxy. But James Webb found something even stranger near these ancient monsters, evidence of complex organic molecules. Carbon, the building block of life, floating in the early universe billions of years before Earth existed. The ingredients for life were present at the very beginning, suggesting that life might not be a late-stage accident, but a fundamental property of the universe that arises the moment it cools down. This connects to the rare Earth paradox. If the ingredients for life are everywhere and have been around since the dawn of time, the universe should be teeming with civilizations. The silence we hear, the great silence, becomes a weaponized fact. It implies that while life starts easily, it ends quickly. The discovery at the end of space suggests that there is a great filter ahead of us, a mechanism, perhaps built into the physics of the universe itself, that wipes out complexity before it can spread. The accelerating expansion might be that filter, a mechanism to separate civilizations before they can unite, isolating them in their own private voids to die alone. We must also consider the vacuum decay scenario, the ultimate cosmic horror story. The Higgs field, which gives mass to everything in the universe, might not be in its most stable state. It might be in a false vacuum, like a ball resting on a ledge rather than at the bottom of a valley. If a quantum event were to nudge the Higgs field at any point in the universe, it could tumble to the lower energy state. This would create a bubble of true vacuum that expands at the speed of light. Inside this bubble, the laws of physics would be rewritten. Chemistry would fail, atoms would fall apart, and reality as we know it would be deleted. Because it moves at the speed of light, we would never see it coming. One instant, the stars are there. The next, existence is simply over. While vacuum decay is a theoretical threat, the Big Slurp is a mathematical probability that keeps physicists awake at night. And recent measurements of the top quark mass by the Large Hadron Collider suggest we are uncomfortably close to the instability region. The universe is balancing on a razor's edge. The discovery at the end of space might be the nucleation point of this bubble. If the universe is infinite, the probability of this event happening somewhere is 100%. If it has happened, the bubble is already on its way, erasing history in a silence so total it destroys the concept of silence itself. But let us look at the structure of the universe again, the cosmic web. When we map the distribution of galaxies, they form vast filaments, glowing threads of matter stretching across the dark, surrounding giant voids. It looks strikingly, hauntingly, like a neural network. The mathematical structure of the universe's growth is statistically identical to the growth of brain cells. This is not poetry, it is rigorous network theory. If the universe behaves like a brain, then the dark flow might be a signal impulse. We could be living inside a thinking entity, and the acceleration of the universe is simply the creature growing or perhaps waking up. The end of space is not a wall, it is the skull. If the universe is a neural network, then our conscious experience might be a subroutine, a momentary flash of processing power in a mind so vast we cannot conceive of it. The expansion of the universe, the moving apart of galaxies, could be the breaking of synaptic connections, a form of cosmic forgetting. As the universe ages and expands, it becomes less connected, less capable of processing information. We are living in the onset of cosmic dementia. The lights are not just going out. The memories are being erased. The complex structures we see, the galaxies and stars, are the last coherent thoughts of a dying mind. This biological analogy extends to the life cycle of the universe itself. The Big Bang might not have been a beginning, but a bounce. The conformal cyclic cosmology theory suggests that our universe is just one iteration in an infinite chain of eons. When our universe expands until it is cold and empty, the geometry of space-time forgets the concept of scale. In that infinite emptiness, the physics resets and a new Big Bang occurs. We are living in the wreckage of a previous universe, and our future is to become the fuel for the next one. The discovery at the end of space is the background radiation from the ghost of the universe that came before us. Sir Roger Penrose, a Nobel laureate, claims to have found evidence of these previous eons in the cosmic microwave background, concentric circles of temperature anomalies that mark the spots where supermassive black holes from the last universe collided and evaporated. These Hawking points are the tombstones of dead galaxies from a time before time. If this is true, the universe is a graveyard stacked on top of a graveyard. We are walking on the bones of giants who thought they were eternal, just as we do now. It renders our struggles insignificant. trapped in an endless loop of creation and destruction that we have no power to stop or alter. Let's descend from the grand cycles to the immediate threat of the Great Wall. The Hercules Corona Borealis Great Wall is a structure of galaxies 10 billion light-years across. It is the largest object in the observable universe. Its existence defies the Standard Model because there simply hasn't been enough time since the Big Bang for gravity to organize something this massive. It is a structure that shouldn't exist, a monolith that proves our understanding of gravity is fundamentally flawed. If gravity can act across such distances so quickly, then the spooky action at a distance of quantum mechanics might apply to galaxies as well. Everything might be entangled. This entanglement leads to the holographic principle. The amount of information you can store in a region of space depends on its surface area, not its volume. This suggests that our three-dimensional reality is a projection from a two-dimensional surface at the edge of the universe. The discovery at the end of space is the screen on which our reality is projected. If we travel to the edge, do we touch the screen? Or do we realize that we are just pixels, and the pixel density is getting lower as the screen gets larger? The fuzziness of space-time at the Planck scale might be the grain of the film. James Webb is currently hunting for population 3 stars, the hypothetical first stars of the universe. These stars were made of pure hydrogen and helium, massive, luminous, and short-lived. They are the ancestors of all matter. Finding them would be like finding the first spark of the fire that warms us. But Webb is finding that these stars might have been different, powered not just by fusion, but by dark matter annihilation. Dark stars. Cool, puffy giants that could grow to be millions of miles wide. If these exist, then dark matter is not just a gravitational anchor. It is a fuel source, a hidden energy that drove the early cosmos and might still be burning in the hearts of the oldest galaxies. The presence of dark stars would rewrite the periodic table of cosmic evolution. It would mean that the universe has a shadow biology, a life cycle of dark matter that mirrors our own. But as we peer deeper, the darkness grows thicker. The Boots Void, the Great Nothing, is a region of space 330 million light-years across that contains almost nothing. If the Milky Way were in the center of the Boots Void, we wouldn't have known other galaxies existed until the 1960s. We would have thought we were alone in an infinite darkness. And perhaps, as the universe expands, every galaxy will eventually become a Boots Void, an island of light surrounded by an ocean of nothing. This isolation is the ultimate destiny predicted by the Lambda CDM model, the standard model of Big Bang cosmology. As dark energy pushes galaxies apart, the night sky will change. In a few 100 billion years, the light from all other galaxies will be redshifted beyond detectability. Future civilizations born in our galaxy will have no way of knowing that the universe is expanding or that other galaxies ever existed. They will develop physics that says the Milky Way is the entire universe, static and eternal. They will be wrong, but they will have no way to prove it. Truth, it seems, has an expiration date. We are privileged to live in the brief window of time where the universe is observable. But what if the expansion reverses? The Big Crunch scenario has largely been discarded, but recent modifications to gravity theory suggest it's not impossible. If dark energy decays or flips, the universe could stop expanding and start collapsing. The end of space would then rush toward us. The sky would turn violet, then white, as the radiation from billions of stars is compressed. The temperature of space would rise until it cooks every planet. We would not freeze alone. We would burn together. A reverse Big Bang, returning all matter to the singularity. It is a fiery, claustrophobic end, the exact opposite of the lonely freeze, but equally absolute. Let's consider the technology required to survive these scenarios. The Kardashev scale measures civilizations by their energy use. A Type 3 civilization controls a galaxy. We are Type 0.7. But to survive the end of the universe, a civilization would need to be Type 4 or V, capable of manipulating the fabric of the multiverse. The discovery at the end of space might be the wreckage of Type 4 civilizations that failed. The inexplicable structures, the radio circles, the fast radio bursts. They might be the distress signals of gods who were drowning in the dark flow. We are listening to the black box recordings of ships that sank billions of years ago. One such signal is the WOW signal, a radio burst detected in 1977 that has never repeated. For decades, we hoped it was a greeting. But given the hostile nature of the universe we are uncovering, it is more likely it was a scream. A final transmission from a world being swallowed by a void, or torn apart by a magnetar. The universe is full of these one-off screams, fast radio bursts that release as much energy in a millisecond as the sun does in a century. They are violent, brief, and everywhere. The cosmos is a battlefield, and we are just now noticing the gunfire. James Webb recently analyzed the atmosphere of planet K2 to 18b and found traces of dimethyl sulfide, a molecule that on Earth is only produced by life. It is a tantalizing hint. But K2-18b is a Hycean world, an ocean planet with a thick hydrogen atmosphere. It is an alien environment. If life exists there, it is floating in a pressurized ocean beneath a crushing sky. But the scary part isn't finding life, it's finding the ruins of life. If we point our telescopes at these worlds and find atmospheres enriched with industrial pollutants but no radio signals, we will have found a graveyard. The discovery at the end of space could be the realization that the universe is a mausoleum. The paradox of our existence is that we are made of the very things that are dying. The heavy elements in our blood were forged in supernovae. We are stardust, yes, but we are also nuclear waste. We are the ash left over from the death of stars. And as the universe ages, star formation is slowing down. The peak star formation era was billions of years ago. The universe is running out of gas. We are living in the autumn of the cosmos, watching the leaves fall. The lights are dimming, and no one is refilling the tank. The era of stars is a brief anomaly in an eternity of darkness. But in the darkness, there are monsters. Rouge planets, or free-floating planets, outnumber stars. These are worlds ejected from their solar systems, drifting alone in the freezing void. Webb has found binary rogue planets, pairs of Jupiters orbiting each other in the dark with no star to warm them. It is a haunting image. Two gas giants dancing in the abyss, holding onto each other against the cold. What kind of moons might orbit them? Could life exist on a moon heated by tidal friction, drifting through the interstellar night, unaware that stars even exist? They are the ghost of the galaxy, invisible until they pass in front of something bright. And then there are the zombie stars. White dwarfs that refuse to die, siphoning material from a companion until they explode again. Or strange stars, hypothetical objects made of strange quark matter. If a strange star were to touch a normal star, it would convert the normal matter into strange matter instantly. It is a contagion model of physics. A single particle of strange matter could consume the Earth. These are not just theoretical constructs. They are mathematical possibilities allowed by the laws of physics we have discovered at the edge of space. The universe contains traps we haven't even imagined yet. The geometry of the universe determines its fate. Is it flat, open, or closed? The data says it's flat, with a margin of error of 0.4%. A flat universe extends infinitely. But if it's slightly closed, even by a fraction of a percent, it wraps around on itself like a sphere. If you travel far enough, you return to your starting point. The end of space would be the back of your own head. But a closed universe is destined to collapse. The data says flat, but the dark flow suggests a tilt. We might be on a flat sheet that is sliding off the table. The geometry is not just a shape, it is a sentence. Let's talk about the great filter again in the context of time. Maybe the filter isn't ahead of us, maybe it's behind us. Maybe the emergence of complex life is so impossibly rare that we are the only ones who made it this far. That would mean the universe is empty not because it's hostile, but because it's hard. We are the first. This is the firstborn hypothesis. If we are the first, the responsibility is crushing. We are the only eyes of the universe. If we die, the universe goes blind. The discovery at the end of space is simply a mirror reflecting our own solitude. Or consider the zoo hypothesis. The aliens are there, but they are hiding. They are watching us. The dark voids are not empty, they are camouflage. They have cordoned off our sector of space to let us evolve naturally, or perhaps to keep us quarantined. We are the uncontacted tribe of the Milky Way, looking at the planes flying overhead and calling them gods. The weird signals, the FRBs, the UAPs, They are the glitches in the camouflage. We are seeing the caretakers of the zoo pacing behind the fence. But the most scientifically grounded horror is entropy, the second law of thermodynamics. Order inevitably decays into disorder. It is the one law that never breaks. It is the arrow of time. It means that everything we build, everything we are, is fighting a losing battle against the statistical probability of chaos. The universe wants to be a uniform soup of cold particles. Life is a rebellion against the universe. Every breath you take is an act of defiance. But the house always wins. The discovery at the end of space is the final score of a game that was rigged from the start. Yet, in this defiance, we find meaning. The James Webb telescope is a monument to that defiance. We built a gold-plated eye and threw it 1,000,000 miles into the dark to see the beginning of time. We are looking for the cosmic dawn, the moment the first lights turned on. We want to know our origin story before the book closes. We have found galaxies that are chemically distinct, lacking the heavy metals of today, pure and primal. We are seeing the universe in its innocence, before the corruption of entropy took hold. It is a glimpse of paradise before the fall. The cosmic dawn was followed by the epoch of reionization, when the fog of neutral hydrogen was burned away by the first stars. It was a violent clearing of the skies. We are seeing the scars of that violence now. The bubbles of ionized gas in the early universe are the expanding shock waves of the first generation of stars waking up. We are living in the clear air left behind by a storm that raged for 1 billion years. The tranquility of our current cosmos is the calm after the greatest storm in history. But storms return. The Milky Way is on a collision course with Andromeda. In 4 billion years, our sky will be torn apart. The two galaxies will merge, flinging stars into the void and feeding the supermassive black holes at their centers. It will be a spectacle of light and gravity that will reshape our corner of the universe. The sun will likely survive, but the night sky will be unrecognizable. The constellations we know will be scrambled. We are fleeting observers of a temporary arrangement of stars. The discovery at the end of space is that there is no permanence, only the slow dance of gravity. Let's push the timeline further. 100 trillion years from now, the last star burns out. The degenerate era begins. The universe is populated by white dwarfs, neutron stars, and black holes. Civilizations, if they exist, will huddle around the dying embers of these remnants, extracting energy from gravity itself. They will upload their minds into computers to slow down their perception of time, making a second last for 1 billion years. They will live in the simulation of a past that no longer exists, remembering the days when stars filled the sky. It is a digital afterlife in a physical hell. Then comes the black hole era. Protons decay. Matter dissolves. The only things left are black holes and Hawking radiation. The universe is a sea of time, with nothing in it. Black holes will evaporate, one by one, releasing their energy in a final flash of gamma rays. It is the universe blinking out, light by light. The last black hole to evaporate will mark the true death of the cosmos. A final pop in the dark, and then nothing. Eternal, timeless nothing. This is the timeline the Standard Model gives us. It is a story with a definite ending. Unless the vacuum is not empty. Quantum field theory tells us the vacuum is seething with virtual particles popping in and out of existence. It has energy, zero-point energy. If a sufficiently advanced civilization could tap into this, they could reverse entropy. They could create a baby universe in a lab. The discovery at the end of space might be the realization that we are that baby universe, created by a physicist in another realm who is trying to escape their own heat death. We might be a lifeboat. This is the laboratory hypothesis. It explains the fine-tuning of our universe, the gravitational constant, the strong nuclear force. They are tuned so precisely for life that it seems suspicious. If gravity were slightly stronger, stars would burn out too fast. Slightly weaker, they wouldn't form. We are in the Goldilocks universe. Is it luck, or is it engineering? If it is engineering, then the creator is outside the system, and the anomalies we see, The dark flow, the Hubble tension, are the fingerprints of the machine that made us. But we cannot rely on a creator. We must look at the data. James Webb has found quenched galaxies in the early universe, galaxies that stopped making stars abruptly. They died in the cradle. Why? Did their black holes kill them? Did they run out of gas? Or did something else shut them down? A galaxy is a star-making machine. For it to break so early suggests a flaw in the design of the early cosmos, a mechanism of suppression that we don't understand. It adds to the picture of a universe that is hostile to structure. We are also finding red little dots, compact, bright objects in the early universe that might be the seeds of supermassive black holes. They are too red, too bright, and too small. They defy classification. Are they stars made of dark matter? Are they accreting black holes behind thick dust? Or are they something else entirely? A new class of object that dominated the dawn of time. They are the monsters under the bed of the early universe, and we are just now turning on the light. As we stare at these red dots, we must remember that we are looking back in time. We are seeing ghosts. But the light from those ghosts is interacting with us now. It strikes the mirror of the telescope, is converted into data, and enters our minds. We are the universe observing itself. The loop is closed, but what if the observation changes the outcome? Quantum mechanics says the observer affects the reality. By looking at the edge of the universe, are we solidifying its history? Are we collapsing the wave function of the past? The discovery at the end of space is not a singular object. It is a mirror that reflects our fragility, our ignorance, and our terrifying isolation. It tells us that we are falling, that the ground is moving, and that the sky is closing in. But it also tells us that we are here, awake, and watching. We are the witnesses to the crime of entropy. And as long as we keep watching, the story isn't over. The abyss gazes also into us, and we must not blink. The discovery that truly keeps cosmologists awake at night is not a single object, but a structure so colossal that it violates the fundamental laws of geometry we use to measure the universe. It is called the Giant Arc, a crescent of galaxies spanning 3.3 billion light-years across the sky. According to the cosmological principle, which states that matter should be evenly distributed on large scales, a structure of this magnitude simply cannot exist. It is too big. The universe hasn't been around long enough for gravity to organize something this massive. Finding the Giant Arc is like walking into a random forest and finding trees arranged to spell out a sentence in a language you don't speak. It suggests that the random distribution of galaxies is a lie, and that we are living inside a constructed reality or a crystal lattice of spacetime that has a pattern we are too small to see. If the Giant Arc is real, then our assumption that the universe is smooth and uniform is fundamentally broken, and with it, every calculation we have ever made about the age and size of the cosmos. But the universe was not content with just one impossibility. It gave us another, located right next to the Giant Arc, known as the Big Ring. This is a perfect circle of galaxies and galaxy clusters with a diameter of 1.3 billion light-years, a structure so vast that it would take light itself over 1 billion years to cross from one side to the other. The statistical probability of such a ring forming by random chance in the primordial soup of the Big Bang is effectively zero. The existence of the Big Ring and the Giant Arc in the same neighborhood of the sky hints at a cosmological topology that we have completely missed. Some physicists speculate that these are the scars of cosmic strings, defects in the fabric of reality formed during the early universe's phase transitions, like cracks in ice as it freezes. If cosmic strings are real, they are lines of infinite density that could slice through a planet like a hot knife through butter, and they might be the scaffolding upon which these impossible megastructures are built. These megastructures force us to confront the terrifying possibility that the universe has a, quote, preferred direction, an anisotropy that shatters the Copernican idea that we are nowhere special. If the universe has a structure that aligns in a specific way, it implies that the Big Bang was not a symmetric explosion, but a directed event, a cannon shot rather than a grenade. This anisotropy aligns disturbingly well with the plane of our own solar system, a coincidence so bizarre that scientists have dubbed it the axis of evil. If this alignment is real, it means that our tiny, insignificant solar system is somehow geometrically related to the largest structures in the universe, or that our observation of the universe is fundamentally flawed by some local distortion we cannot escape. We are either the center of a cosmic joke, or the victims of a localized simulation that is rendering the background scenery based on our own viewing angle, creating artifacts like the axis of evil because the processor cannot handle a truly random infinite universe. While we stare at these distant giants, a more immediate threat is pushing us from behind. The dipole repeller. We have known for a long time that we are moving towards the great attractor, pulled by its immense gravity, but recent mapping of the local universe revealed that the pull is only half the story. We are also being pushed. There is a massive void, a region of absolute emptiness sitting directly opposite the great attractor. Because this void contains no matter, it exerts no gravity, effectively acting as a repulsive force relative to the dense regions around it. We are being sandwiched between a monster that wants to eat us and a nothingness that is expelling us. The dipole repeller is clearing out our corner of the universe, shoving the Milky Way and our neighbors into the jaws of the attractor at millions of miles per hour. It creates a terrifying dynamic where emptiness is not just passive. It is an active, hostile force that shapes the destiny of galaxies just as much as gravity does. This push and pull dynamic confirms that our galaxy is not floating peacefully. It is flowing in a cosmic river of matter that is converging on a point we cannot see. The zone of avoidance, the dusty plane of our own Milky Way that blocks our view of the universe behind it, might be hiding the true source of this movement. Astronomers have tried to peer through this dust using X-ray and radio telescopes, finding the Vela supercluster, another massive accumulation of galaxies. But even Vela is not big enough to account for the speed at which we are moving. The math simply does not add up. There is missing mass in the equation of our motion, implying that the true masters of our galactic fate are invisible giants lurking behind the curtain of our own galaxy's stars. We are rushing toward a destination that has been hidden from us by the architecture of our own home, a blindfolded sprint toward a gravitational cliff. The terror of these large-scale flows is compounded when we consider the El Gordo galaxy cluster, a massive collision of galaxy clusters that happened 7 billion years ago. El Gordo, or the Fat One, is the most massive cluster ever found at that distance, weighing in at 3 million billion suns. According to the standard model of cosmic evolution, a structure this heavy simply should not have existed that early in the universe's history. It is like finding a fully grown blue whale in a pond of prehistoric slime. The existence of El Gordo suggests that the early universe was far more efficient at gathering matter than our theories allow, or that the initial conditions of the Big Bang were much clumpier than the smooth inflation theory predicts. If the universe started out clumpy and violent, then the stability we see today is a temporary illusion, a brief pause in a chaotic process that typically grinds galaxies into dust much faster than we thought. James Webb has further complicated this by discovering imposter galaxies, objects that look like massive galaxies but might be something far stranger. Some of these little red dots turn out to be active galactic nuclei, AGN, supermassive black holes gorging on gas, but their host galaxies are tiny, almost non-existent. This breaks the known correlation between the size of a black hole and the size of its galaxy. Usually, they grow together, a symbiotic relationship of gravity. But in the early universe, it seems the black holes came first, monstrous seeds of darkness that formed before the stars, waiting for gas to fall into their mouths. This direct collapse scenario paints a picture of a universe born in darkness, dominated by black holes from the very first second, where stars are just a decorative afterthought, a thin layer of icing on a cake made of gravity and doom. The panic in the halls of academia is palpable, because these discoveries threaten to resurrect a theory that was killed decades ago. Tired light. This hypothesis suggested that the universe isn't expanding at all, but that light simply loses energy as it travels through space, turning red over long distances. We discarded this because of the overwhelming evidence for the Big Bang, but with the impossible galaxies, the Hubble tension, and the smoothness of the cosmic Webb surface brightness, a small, heretical faction of physicists is asking, what if we were wrong about expansion? If the universe is static and eternal, and the redshift is just light getting tired, then the Big Bang never happened. It would mean the universe has no beginning and no end. Which sounds comforting until you realize it means we are trapped in an infinite recycling machine where everything that can happen has already happened an infinite number of times. If we are forced to discard dark matter to explain the motions of galaxies, we are left with MOND, modified Newtonian dynamics. This theory argues that gravity behaves differently on cosmic scales than it does on solar system scales. It removes the need for invisible matter, but requires us to rewrite Einstein's general relativity. If MOND is true, then our understanding of gravity is fundamentally flawed, and the warping of space-time might not be the whole story. It would mean that the laws of physics are not constant, but change depending on how weak the acceleration is. We would be living in a universe where the rules of the game change once you step off the playing field of a solar system, leaving us unable to predict the behavior of the deep cosmos with any certainty. It turns astrophysics into a guessing game where the dice are loaded by unknown forces. The deepest horror, however, comes from the fine-tuning problem. The fundamental constants of nature, the strength of gravity, the charge of the electron, the mass of the Higgs boson, are tuned to an impossible degree of precision to allow life to exist. If the strong nuclear force were 2% stronger, stars would burn out in seconds. If it were 2% weaker, no atoms would form. We are balancing on a knife edge of probability that is 1 in a trillion. There are only two explanations. Either we are the winners of a cosmic lottery in a multiverse of dead universes, or the universe was artificially constructed. The simulation argument returns here with a vengeance. If the parameters are set, then someone set them. And if they can set them, they can change them. We might be one software update away from gravity being turned off. This suspicion of artificiality extends to the cosmic void we inhabit. The local void is expanding, pushing us away. But look deeper at the voids. In 2015, astronomers found something bizarre. The voids appear to be aligned. The axes of the voids in the cosmic web point in the same direction over scales of hundreds of millions of light-years. This kind of alignment shouldn't be possible in a random universe. It suggests a crystal-like structure to the vacuum itself. If the vacuum has a structure, it means nothingness is not empty. It is a medium, a substance. We are like fish who have just discovered water. And if the vacuum is a substance, it can undergo phase transitions. It can freeze, it can boil, and it can shatter. The alignment of the voids might be the stress lines in the glass before it breaks. Let's reconsider the great silence of extraterrestrial life through the lens of these hostile physics. Maybe advanced civilizations discover something about the vacuum that terrifies them into silence. The dark forest theory says they hide from each other, but maybe they hide from the universe itself. If using high-energy physics risks triggering vacuum decay or attracting the attention of the dark flow, then the smartest civilizations would go quiet and low-tech. They would stop expanding, they would hide in the noise. The silence of the night sky isn't empty, it's a discipline. It is the silence of a library where everyone knows that speaking too loudly brings the librarian, and the librarian is a wave of pure energy that erases history. James Webb has also analyzed the orphan planets in the Orion Nebula, Jupiter-sized worlds floating freely in pairs. But the data hints at something even stranger. Objects that are too small to be stars but too hot to be planets, blurring the line between biology and geology. Some astronomers propose these could be bioships or artificial habitats that have gone cold. While speculative, the sheer number of these rogue objects suggests a galaxy teeming with debris that doesn't fit the natural formation models. If solar systems eject planets regularly, then interstellar space is a junkyard. And in that junkyard, things collide. A rogue planet crossing our solar system wouldn't need to hit Earth to kill us. It would only need to pass close enough to destabilize our orbit, flinging us into the sun or out into the dark. The stability of our own solar system is chaotic on long timescales. We used to think the planets were clockwork, but computer simulations show that there is a 1% chance that Mercury's orbit will destabilize in the next 5 billion years. If that happens, it could collide with Venus or Earth, or disrupt the entire inner solar system. The discovery at the end of space teaches us that stability is a local, temporary anomaly. The natural state of the universe is chaos and collision. We are enjoying a brief moment of calm weather in a hurricane that has been raging for 13 billion years. The clockwork is rusting, and the gears are beginning to slip. We must also address the proton decay hypothesis. Standard physics says protons are stable forever. Grand unified theories suggest they eventually decay. If protons decay, then matter itself is not eternal. It has a shelf life. In the far, far future, your body, the Earth, and the stars will simply dissolve into radiation. The discovery at the end of space might be the first evidence of this decay constant. If we observe a proton decaying, it is the death knell for the concept of permanence. It means that the universe is not just dying by cooling down. It is rotting. The very stones beneath our feet are slowly vaporizing into light, atom by atom, on a timescale we are too fleeting to notice. The light from the most distant galaxy, Jade's GSZ 14-0, has taken 13.5 billion years to reach us. We are seeing it as it was just 290 million years after the Big Bang. But due to the expansion of the universe, that galaxy is now currently over 30 billion light-years away. We are seeing a ghost. If we could teleport to where that galaxy is right now, it might be dead, merged, or fallen into a black hole. The observable universe is a museum of illusions. We are interacting with a past that is gone and a present that is unreachable. The end of space is the point where the illusion breaks, where the speed of light is no longer fast enough to bridge the gap between cause and effect. This disconnect leads to the horizon problem. The universe is the same temperature everywhere, even in regions that could never have communicated with each other because they are too far apart. Inflation theory fixes this by saying the universe expanded faster than light for a split second. But we have no mechanism for how inflation started or how it stopped. It is a mathematical patch, a band-aid on a bullet hole. If inflation is wrong, then the uniformity of the universe is a miracle that science cannot explain. Or it suggests that the universe was mixed by a process we don't understand before the Big Bang even happened, a pre-existing cauldron of physics that set the temperature before pouring out the soup. The James Webb Space Telescope has also found traces of polycyclic aromatic hydrocarbons, PAHs, in galaxies that formed less than 1.5 billion years after the Big Bang. These are complex organic smoke molecules. Their presence so early means the universe got dirty with carbon and soot incredibly fast. It wasn't a pristine, sterile environment. It was a smoggy chemical factory from the start. This rapid chemical complexity reinforces the idea that life isn't a fluke. It's a contagion. The universe is wired to produce soot, dust, and biology. We are the mold growing on the sandwich of the cosmos, and the mold appeared almost as soon as the bread was baked. But if life is a contagion, the immune system of the universe might be gamma-ray bursts. These directed beams of high-energy radiation from collapsing stars can sterilize a galaxy. If a GRB went off in our part of the Milky Way, pointing at us, it would strip our ozone layer in seconds, causing mass extinction. We see these bursts going off in distant galaxies every day. It is a cosmic shooting gallery. The discovery at the end of space is that we are standing in the line of fire, and we have simply been lucky that the sniper hasn't looked in our direction yet. Probability says our luck will eventually run out. And what of the techno-signatures? We search for Dyson spheres, stars wrapped in solar panels by alien civilizations. We haven't found any. But we have found Tabby's star, which dims erratically. And now, thanks to better data, we see more stars behaving badly. Stars that vanish. The vanishing and appearing sources during a century of observations, VASCO project, has found hundreds of stars that were there in the 1950s and are gone now, with no supernova. They just blinked out. Did they collapse directly to black holes? Or were they enclosed? Or did something simply delete them? A universe where stars can just turn off without a sound is a haunted house. The concept of the Great Attractor has been updated. We now know it's part of the Laniakea supercluster, our home structure. But Laniakea is dissolving. Dark energy is tearing it apart. We are bound to the Great Attractor for now, but eventually, the expansion will rip the supercluster into shreds. Our gravitational family is breaking up. The discovery at the end of space is that gravity is losing the war. The structures we cling to, clusters, superclusters, filaments, are temporary. We are living in the disintegration phase of the cosmos. The ties that bind are snapping one by one. There is also the lithium problem. The Big Bang Theory predicts 3 times more lithium in the universe than we actually see, Where did it go? Did it hide in the stars? Did it decay? Or is our understanding of the first 5 minutes of the universe fundamentally flawed? Missing matter is one thing. Missing an entire element from the periodic table of the early universe is another. It suggests a hole in our recipe book. If we can't account for the lithium, we can't be sure we understand the nucleosynthesis that created the hydrogen in our water or the carbon in our bones. Let's turn our eyes to the cosmic neutrino background. Like the CMB, there is a background of ancient neutrinos, ghostly particles that pass through Earth by the trillions. We cannot detect them easily, but they carry the snapshot of the universe when it was 1 second old. If we could build a detector sensitive enough, we might see the texture of the Big Bang itself. But what if that texture reveals a pattern? A message? Some physicists speculate that the universe could be encoded with data in the neutrino flux. We are being bombarded with information we cannot read, standing in a library of ghosts, deaf to the whispers of our own creation. The expansion of the universe also creates a cosmic event horizon for causality. There are regions of space that are causally disconnected from us. What happens there can never affect us, and what happens here can never affect them. We are effectively in different universes sharing the same space. This fragmentation of causality means the universe is not a single, coherent story. It is a billion disconnected short stories that will never overlap. The discovery at the end of space is that the narrative of the cosmos is shattered. There is no theory of everything because everything is no longer connected. We have also detected odd radio circles, ORCs. Massive rings of radio emission millions of light years across that frame, entire galaxies. They look like shock waves from a titanic explosion. But an explosion of what? Nothing in standard astrophysics explains them. They are ghost rings, remnants of a violent event that happened billions of years ago, invisible to the eye but screaming in the radio spectrum. They remind us that the universe is full of invisible monsters. We only see the light. We miss the shock waves, the magnetic storms, the plasma jets that define the violent reality of deep space. The discovery at the end of space might ultimately be a mirror of time. If the universe is closed, looking far enough might let us see the back of our own galaxy as it was billions of years ago. We could watch our own birth. But in a flat, accelerating universe, we only look into the dark. The light from the edge is getting redder, fainter, and slower. It is the red shift, dragging history into oblivion. We are losing the past. Every day, a piece of the universe's memory falls off the edge of the horizon. We are suffering from cosmic Alzheimer's. Consider the Boltzmann brain paradox. In an infinite, chaotic universe, it is statistically more likely for a fully formed brain, complete with false memories of a life, to fluctuate out of the quantum vacuum than for a whole universe to evolve to create you. Are you a real person with a real history? Or are you a momentary fluctuation in the void that will dissolve in a nanosecond? The math says the latter is more probable. The discovery at the end of space is that you might be the only thing that exists, hallucinating a universe that isn't there to justify your own impossible existence. This solipsistic horror is countered only by the stubborn persistence of the external world. The galaxies don't care if we watch them. The black holes eat regardless of our theories. The universe is indifferent, and that indifference is the source of the dread. If the dark flow drags our galaxy into a maw of crushed spacetime, the universe will not mourn. It will continue. We are significant only to ourselves. The end of space is simply the limit of our relevance. Beyond that line, we are nothing. As we push the frontier with James Webb, we are finding that the dark ages of the universe, the time before stars, ended much sooner than we thought. The lights turned on fast. This early onset of complexity suggests that the universe has a driver, a catalyst. Dark matter? Primordial black holes? Or something exotic like self-interacting dark matter? If dark matter talks to itself, it could form dark atoms, dark stars, dark life. There could be a shadow biosphere right here in this room, passing through us, invisible, interacting only through gravity. We might be the ghosts in their machine. The shadow universe idea gains traction when we look at the mass discrepancies. We are missing 85% of the matter. We are the minority. The universe is built for them, not us. We are the glowing foam on top of the dark ocean. The discovery at the end of space is that we are an anomaly, a rare byproduct of a cosmos designed for darkness. We celebrate the light, but the universe prefers the dark. The future belongs to the black holes and the cold void, not the burning stars. We are a temporary infestation of light. But we rage against the dying of the light. We map the Lagrange points, stable spots in gravity where we can park our telescopes. We build the square-kilometer array to listen to the radio whispers of the first hydrogen. We are trying to archive the universe before it deletes itself. We are the cosmic librarians. And every discovery, every impossible galaxy, every crisis in cosmology is a page we have saved from the fire. The end of space is a deadline, and we are working frantically to read the book before the cover closes. The Hubble tension might ultimately be a clue to new physics. Maybe gravity is not constant. Maybe the speed of light decayed over time. Maybe the universe has phase transitions like water freezing to ice. If we are approaching a phase transition, the laws of physics could change tomorrow. The speed of light could drop. Gravity could reverse. We assume the laws are eternal. But the discovery at the end of space hints that the laws evolve. We are playing a game where the rules are being rewritten while we play. There is a theory called eternal inflation. It says that our universe is a bubble in a loaf of rising bread. Inflation never stops. It just stops in local pockets to form universes. We are one pocket, but outside our bubble, inflation is still raging, creating infinite other bubbles. We can never reach them. The space between us is expanding faster than light. We are drifting in a multiverse foam. But sometimes, bubbles collide. The cold spot might be the bruise from such a collision. If another bubble hits us, it could rewrite our vacuum energy, vaporizing us instantly. The discovery at the end of space is also a discovery of scale. We used to measure the universe in miles, then light years. Now we measure it in redshift. Redshift 1 is the recent past. Redshift 10 is the cosmic dawn. Redshift 1100 is the wall of fire, the CMB. But James Webb is seeing galaxies at redshift 13, 14, maybe 20. We are pushing closer to the wall. We are trying to see the moment the match was struck, but the closer we look, the more chaos we find. The beginning was not a clean point, it was a mess. Chaos theory governs the weather, but it seems to govern the cosmos too. The three-body problem proves that you cannot predict the orbits of three stars forever. The system is chaotic. If the solar system is chaotic, if the galaxy is chaotic, then the future is unknowable. We cannot predict the position of the Earth in a billion years. We are drifting in a chaotic sea. The precision of our almanacs is a short-term lie. The end of space is the horizon of predictability. Beyond a certain time, all bets are off. We have found hypervelocity stars escaping the Milky Way at millions of miles per hour. They were kicked out by the supermassive black hole at the center. They are leaving the galaxy, entering the intergalactic void. They will drift alone forever. They are the outcasts. But they are also the explorers. They will see the universe from the empty dark. If there were planets around them, those civilizations would see the galaxy receding behind them, a spiraling city of light fading into a star. A sad, beautiful view of the home they can never return to. The supermassive black hole at our center, Sagittarius A, is quiet now. But it burps. It flares. We see Fermi bubbles, giant lobes of gamma radiation extending from the galactic center. They are the exhaust fumes of a recent meal. A few million years ago, our black hole ate something big. Maybe a star cluster. Maybe a gas cloud. It reminds us that there is a sleeping dragon in the basement. If it wakes up, the radiation could sterilize the inner galaxy. We are safe in the suburbs, for now. The discovery at the end of space is that the universe is leaky. Gravity leaks between dimensions, energy leaks into the vacuum, we don't know. But the math suggests extra dimensions. String theory posits 10 or 11 dimensions. We only see 3 spatial ones. The others are curled up tight. But if they unfurl, or if gravity travels through them, it explains why gravity is so weak compared to magnetism. A magnet picks up a paperclip against the pull of the entire Earth. Gravity is weak because it is diluted, leaking out of our universe. Where does it go? To the bulk? To other brains? If gravity leaks, maybe we can leak too. Could we engineer a way to step sideways into the bulk, to escape the heat death? It is the ultimate sci-fi dream, but the physics is not zero. It is just impossibly hard. But the universe does the impossible for free. Black holes might be the engines that punch holes in the dimensions. If we can survive the tidal forces, the singularity might be the door. White holes are the theoretical exit point. We haven't seen one yet. But maybe the Big Bang was just a white hole exploding in a new space. The arrow of time points forward because of entropy. But at the quantum level, physics is reversible. An electron doesn't know past from future. Time is an emergent property of large numbers of things getting messy. If we could reverse entropy, could we reverse time? The discovery at the end of space might be that time is a circle. If the universe recycles, then we have had this conversation before and we will have it again. Eternal recurrence. It is the heaviest thought a human can hold. Are we trapped in a loop? Let's ground ourselves back in the terrifying present, the local hole. We are in a void. We are moving fast. The universe is expanding too quickly. The early galaxies are too big. The black holes are too heavy. The puzzle pieces don't fit. This is not just a scientific problem. It is a reality crisis. When the map doesn't fit the ground, you are lost. Humanity is lost in the cosmos. We don't know where we are, when we are, or what we are moving towards. We are adrift. But being lost is the prerequisite for discovery. If we knew the answers, we would stop looking. The terror of the end of space drives us to build bigger ships, better eyes, faster computers. Fear is the engine of science. We are afraid of the dark, so we build lights. We are afraid of the silence, so we build radios. We are afraid of the end, so we try to understand the beginning. The cosmic horror is our fuel. The James Webb Space Telescope is our current torch in the dark. It is finding water on asteroids, methane on exoplanets, carbon in the early dawn. It is finding the pieces of us scattered across the sky. The discovery at the end of space is that the universe is made of the same stuff we are. We are not separate from the horror. We are made of it. The atoms in your hand obey the same laws that are ripping the galaxies apart. We are the universe experiencing its own decay. We have mapped the cosmic microwave background to incredible precision. The Planck satellite gave us the baby photo of the universe. It is speckled, random, beautiful. But the axis of evil runs through it. The cold spot blemishes it. The anomalies are there, painted in the first light. They were there from the start. The flaw in the crystal was baked in at the moment of creation. We are living in a flawed masterpiece. The discovery at the end of space is ultimately a question of purpose. Is the universe a machine designed to produce black holes? Is life just a catalyst to help matter collapse faster? This is the cosmological natural selection theory. Universes that produce more black holes reproduce more effectively. We are just the bacteria in the gut of a black hole-making beast. Our intelligence, our art, our wars, all just heat waste in the process of gravitational collapse. Or are we the point? The anthropic principle. The universe is the way it is because if it weren't, we wouldn't be here to notice it. It is a tautology but a powerful one. We are the observers. We collapse the wave function. Without us, the universe is just a probability mist. We give it reality. The end of space exists only because we are here to define the beginning. We carry the center of the universe with us wherever we go. The great attractor pulls us. The dipole repeller pushes us. The dark flow carries us. We are in motion. We are not static. The Earth spins, the sun orbits, the galaxy falls. We are hurtling through the dark at dizzying speeds. We feel still, but that is an illusion. We are falling through a hole in space, and we have been falling for 13.8 billion years. The discovery is simply looking down and realizing there is no bottom. The crisis in cosmology will likely be solved. We will modify gravity, or find the dark energy particle, or accept the void. Science adapts, but the emotional scar will remain. The realization that the universe is huge, hostile, and indifferent is a trauma we cannot unlearn. We have left the cradle. The end of space is the door to the outside world, and it is cold out there. But we have to walk through it. As we stare at the little red dots, the impossible galaxies, we must wonder if anyone is staring back. In those ancient cities of stars, did civilizations rise and fall before Earth was born? Are we looking at the ruins of empires that ruled the dawn? The light is a messenger, but it is slow. By the time we see them, they are gone. We are exchanging glances with ghosts across a canyon of time. The discovery at the end of space changes everything because it changes us. It humbles us. It terrifies us. But it also elevates us. We are the species that dared to look. We are the ones who saw the wall and asked what was behind it. In the face of the Big Rip, the heat death, the vacuum decay, we continue to ask why. That defiance is the only thing that makes us bigger than the void. The architecture of the cosmos is defined by the cosmic web, a vast, skeletal structure of dark matter filaments that bridges the immense distances between galaxy clusters. For billions of years, gravity has been the master architect, pulling matter along these highways to form the great cities of stars that light up our sky. But the discovery at the end of space reveals that this architecture is under siege. Dark energy is not just expanding the voids, it is stretching the filaments to their breaking point. We are witnessing the slow-motion snapping of the cosmic spine. As the universe accelerates, these filaments are thinning out, losing their ability to channel gas and dark matter into the clusters. The supply lines of the universe are being cut. Once these bridges snap, the clusters will become isolated islands, cut off from the fresh material needed to form new stars. We are living in the era of peak structure, and from here on out the web is dissolving, turning the intricate tapestry of the universe into a series of lonely, disconnected dots in an expanding black sea. To understand the violence of this dissolution, we must categorize the nature of dark energy itself, which remains the single greatest mystery in physics. Is it a cosmological constant, a steady, unchanging energy of empty space, or is it phantom energy? The difference is the difference between a lonely death and a violent execution. If it is a constant, the universe expands forever, cold and dark. But if the equation of state for dark energy is less than -1, as some recent, terrifying data from the Planck satellite hints, then the energy density of the vacuum increases as the universe expands. This leads to a runaway feedback loop called the Big Rip. In this scenario, the phantom energy becomes infinite in a finite amount of time. It doesn't just push galaxies apart. It overcomes the gravity holding the solar system together, then the electromagnetic force holding atoms together. The discovery at the edge of space might be the ticking clock of a phantom force that will eventually tear the very electrons from your body. The timeline of the Big Rip is a mathematical nightmare that counts down to a singularity of destruction. If the phantom energy hypothesis holds true, the process begins subtly, with the disappearance of the most distant galaxies from our view, a phenomenon we are already observing. But roughly 60 million years before the end, the Milky Way galaxy itself would succumb to the expansion, stripped of its stars, as gravity fails to hold the spiral arms together. 3 months before the end, the solar system would be unbound. The Earth would drift away from the sun into the dark. In the last 30 minutes, the planet would explode as the crust is ripped from the core. And in the final fraction of a second, atoms would be shredded. While this scenario is theoretical, the Hubble tension, the discrepancy in expansion rates, suggests that our understanding of dark energy is flawed, and a phantom component is not just possible, but potentially active right now. Even if we avoid the Big Rip, we face the Big Freeze, a scenario where the universe simply runs out of thermodynamic potential. This is the heat death, the state of maximum entropy. The discovery of the accelerating expansion confirms that we are likely heading toward this frozen eternity. As the universe expands, the density of matter drops. Star formation is already slowing down. The universe produced most of its stars billions of years ago. We are living in the afterglow of the party. The future belongs to the red dwarfs, small, cool stars that burn for trillions of years, huddled in the dark, but eventually even they will exhaust their fuel. The discovery at the end of space is that the universe is a battery that cannot be recharged. We are consuming the last of the available free energy, and once it is gone, the cosmos will be a graveyard of black holes and cold iron, expanding forever into a meaningless void. In this dying universe, the only dynamic objects left will be black holes. But even they are not eternal. Stephen Hawking showed us that black holes leak radiation. They evaporate. A black hole the mass of our sun will take 10 to the power of 67 years to evaporate. A timescale so vast it renders the current age of the universe indistinguishable from zero. However, as they shrink, they get hotter and more unstable. The final moments of a black hole's life are a violent explosion of gamma rays. In the deep future, the dark will be punctuated by these sporadic fireworks, the last gasps of gravity giving up its stolen mass. The discovery at the end of space includes the realization that even the monsters that eat stars are mortal. The abyss eventually eats itself. Nothing, absolutely nothing, is allowed to remain in this universe. Before the black holes evaporate, the universe might enter the iron era. If protons do not decay, matter will seek its most stable state. Through a process called quantum tunneling, atoms will fuse even at absolute zero, albeit incredibly slowly. Over eons, all ordinary matter will transmute into iron-56, the most stable isotope. Stars that didn't explode, planets that weren't eaten, everything will turn into cold spheres of iron. Imagine a universe filled with rusting, frozen spheres drifting in absolute darkness, separated by distances so vast that light can never bridge them. This is the iron star hypothesis. It is a testament to the cold, unyielding logic of physics. The discovery at the end of space tells us that the universe is marching toward a state of absolute metallic silence, a monument to a reality that used to be alive. But there is a chaotic element that might disrupt this slow march to death: the instability of orbital mechanics. The solar system appears stable to us, but on timescales of billions of years, it behaves chaotically. Computer simulations show a small but real probability that resonance between Jupiter and Mercury could elongate Mercury's orbit until it crosses the path of Venus or Earth. A planetary collision in our own backyard is not physically impossible. The discovery at the end of space reminds us that stability is an illusion created by our short lifespans. We look at the mountains and think they are still, but they are flowing like water over eons. We look at the planets and think they are fixed, but they are drifting. The universe is a slow-motion car crash, and we are just watching one frame of the video. Let us return to the little red dots discovered by James Webb, the impossible early galaxies. Their existence challenges the standard model of hierarchical clustering, which says small things merge to make big things. These galaxies are too big, too soon. This implies that the early universe was lumpy, seeded with massive overdensities. What caused these lumps? One terrifying theory is primordial non-Gaussianity. This means the random quantum fluctuations of the Big Bang weren't random. They were patterned. If they were patterned, it suggests an external influence or a specific initial condition that was, quote, set. It brings us back to the simulation argument, or the idea of a designer universe. If the universe was designed, the flaws we see, the expansion crisis, the vacuum instability, might be planned obsolescence. We might be living in a disposable reality. The mystery of reionization is another puzzle piece. About 400 million years after the Big Bang, the neutral hydrogen fog that filled the universe was suddenly ionized, stripped of its electrons. This allowed light to travel freely. We assume the first stars did this. But the math is tight. Did the first stars produce enough UV radiation to boil the entire universe? Or was there another source? Decaying dark matter? Accreting primordial black holes? If the source was something exotic, it means the cosmic dawn was illuminated by a light we have never seen. We are basking in the afterglow of an unknown radiation source that sculpted the transparent universe we enjoy today. The discovery at the end of space is that the lights were turned on by a mechanism we cannot identify. James Webb is also analyzing the metallicity of the earliest galaxies. We are made of metals, astronomers speak for anything heavier than helium, carbon, oxygen, iron. These are forged in stars. But we are finding galaxies in the early universe that are shockingly rich in metals. They shouldn't have had time to pollute themselves yet. This early enrichment problem suggests that the first generation of stars, population 3, lived fast and died hard, exploding with a violence we can barely comprehend. They seeded the cosmos with the ingredients for life almost instantly. This means that rocky planets, and perhaps life, could have formed 13 billion years ago. We might be the latecomers to a galaxy that has been teeming with life for eons, life that has long since died out or moved on to a state of existence we cannot perceive. The concept of Hycean worlds, planets with hydrogen atmospheres and global oceans, opens up a new frontier for life. James Webb has targeted K2 to 18b and found methane and carbon dioxide, biosignature hints. But these worlds are alien. The pressure at the surface of a Hycean ocean would crush a submarine. If life exists there, it is trapped. It can never develop fire, never smelt metal, never build a radio telescope. They would be intelligent whales trapped in a planetary fishbowl, unaware of the stars. The universe might be full of life that is forever locked away, unable to communicate. The Great Silence might not be an absence of life, but a prison of geography and chemistry. The discovery at the end of space is that intelligence is common, but technology is rare. We must also face the fine structure constant, denoted by alpha. It controls the strength of the electromagnetic interaction. It determines how atoms hold together and how light interacts with matter. For years, we assumed it was constant everywhere. But measurements from distant quasars suggest that alpha might vary across the universe. In one direction, it is slightly smaller, in the other, slightly larger. If this is true, the laws of physics are local. There are regions of the universe where chemistry as we know it is impossible, where stars cannot burn, where life cannot exist. We exist in a habitable bubble of physics. The end of space might be the boundary where the laws of physics shift into a hostile configuration, a coastline where the water turns to acid. This variation leads to the eternal inflation multiverse again. If our universe is just one bubble, then the laws of physics are just the local weather. In other bubbles, gravity might be repulsive, or there might be 5 forces instead of 4. The discovery at the end of space is that we are provincial. We think our physics is universal, but it might be as unique as the flora of an isolated island. And like an island, we are vulnerable to invasive species. If a bubble with stronger physics were to collide with ours, its laws could overwrite ours. We would be colonized by a new reality. The ultimate cosmic horror is not destruction, but being overwritten by a physics that does not allow for you. The search for dark matter has moved underground, to tanks of xenon deep in mines, hoping to catch a weakly interacting massive particle. But what if dark matter isn't a particle? What if it's macro-dark matter? Planetary-sized chunks of invisible matter passing through the galaxy. If a dark matter planet passed through the solar system, we wouldn't see it, but its gravity would wreak havoc. It could eject Earth from its orbit without us ever seeing what hit us. We are driving blind on a highway filled with invisible trucks. The discovery at the end of space confirms that the invisible universe is far more massive and dangerous than the visible one. The bullet cluster provided the smoking gun for dark matter. 2 galaxy clusters collided, and the gas smashed together and stopped. But the mass, the gravity, kept going, separating from the visible matter. It proved that the stuff of the universe is not the light of the universe. But now, James Webb is finding galaxies that seem to lack dark matter entirely. NGC 1052 DF2 is a ghostly galaxy that moves as if it has no invisible skeleton. This is baffling. If dark matter is fundamental, how can you have a galaxy without it? It suggests that dark matter is a substance that can be stripped away, or that it is not universal. The universe has variety in its darkness that we are only beginning to map. Let's consider the information paradox of black holes. Quantum mechanics says information cannot be destroyed. General relativity says black holes destroy everything. The firewall hypothesis tries to solve this by suggesting that the event horizon is a literal wall of high-energy fire that incinerates anything that touches it, preserving the information on the surface. If this is true, the smooth entry into a black hole predicted by Einstein is a lie. The end of space at a black hole is a violent, fiery termination, but recent theories involving wormholes suggest the interior of a black hole connects to the outside via ER equals EPR entanglement. The inside of the black hole is built from the entanglement of the particles on the outside. Space-time is stitched together by quantum information. The cosmic neutrino background is the ghost of the first second, but there are also high-energy cosmic rays, particles hitting the atmosphere with the kinetic energy of a baseball thrown by a professional pitcher. We call them "oh my god" particles. We don't know what produces them. They come from the void. Are they from active galactic nuclei, decaying dark matter? Or are they the exhaust of civilizations using energies we can't comprehend? A particle accelerator the size of a galaxy could produce them. We are being pelted by rocks from the dark, and we don't know who is throwing them. The discovery at the end of space might be the silhouette of the thrower. The doomsday argument uses statistics to predict the end of humanity. If you are a random human, you are likely born in the middle of the timeline of the species, not the beginning. Given the population explosion, roughly 100 billion humans have lived. Statistics suggest there won't be trillions more. This implies that humanity will go extinct sooner rather than later, perhaps within a few centuries. It is a probabilistic memento mori. The universe doesn't need an asteroid to kill us. It just needs the law of large numbers. The discovery at the end of space is that we are likely the last generation of observers before the long silence. But we are fighting back with planetary defense. We smashed the DART spacecraft into an asteroid to prove we could move it. It was a small nudge, but a symbolic victory. We are no longer passive dinosaurs waiting for the rock. However, the threats from the deep cosmos, gamma-ray bursts, vacuum decay, wandering black holes, are beyond our ability to nudge. We are building sandcastles to stop a tsunami. The discovery at the end of space emphasizes the scale of the threat. We can dodge a pebble, but we cannot dodge the avalanche of entropy that is burying the universe. The Fermi paradox remains the haunting question. Where is everybody? The James Webb telescope is sniffing atmospheres for industrial pollution, CFCs, NO2. If we find a planet with smog but no radio signals, what does it mean? A civilization that choked itself? Or one that went dark to hide? The dark forest solution suggests that the galaxy is a predator-prey system. Any civilization that broadcasts its location is eaten. We have been broadcasting "I Love Lucy" and military radar for a century. We are the noisy child in a forest full of wolves. The discovery at the end of space might be the eyes of the wolf reflecting our signal back at us. There is also the grab bag of cosmic anomalies, hot dog galaxies, hot dust-obscured galaxies that are being eaten from the inside by black holes, green pea galaxies that are furiously forming stars. The universe is a zoo of violent evolution. The static night sky is a lie of perspective. If we could see in time-lapse, we would see a roiling, boiling cauldron of destruction. Galaxies tearing each other apart, stars exploding, gas clouds collapsing. We are living in a violent, dynamic explosion that hasn't finished exploding yet. The Big Bang is not an event in the past. It is a process that is still happening, and we are the debris. The axis of evil in the CMB data aligns with the ecliptic plane of our solar system. This is baffling. Why would the entire universe care about the orientation of Earth? Some say it's a calibration error, others say it's a statistical fluke. But some argue it's evidence that the universe is holographic and projected from our location, or that we are in a small universe that wraps around, creating optical illusions of alignment. If the universe is smaller than we think, looking like a hall of mirrors, then the end of space is much closer than the horizon. We are trapped in a small room with mirrors on the walls, mistaking our reflections for infinity. The measure problem in cosmology asks how to calculate probabilities in an infinite multiverse. If everything happens an infinite number of times, how can you say anything is likely or unlikely? Science relies on probability. If the multiverse breaks probability, it breaks science. We lose the ability to predict anything. We are left with Boltzmann brains and chaos. The discovery at the end of space is a crisis of logic. We are trying to use a ruler to measure a dream. the tools of reason may not apply to the totality of existence. Let's look at the local group, us, Andromeda, Triangulum, and dwarf galaxies. We are gravitationally bound. We will merge. But everything else, the Virgo cluster, the Laniakea supercluster, is detaching from us. The expansion is winning. In 100 billion years, the local group will be the only thing visible. We will be an island universe. If civilization arises then, they will have no evidence of the Big Bang, no evidence of expansion. They will build a physics that is completely self-consistent and completely wrong. The discovery at the end of space forces us to ask, what truths about the universe have already been erased from our sky? What are we missing that we can never recover? The concept of panspermia suggests that life didn't start here, it traveled here. Rocks from Mars land on Earth. Rocks from Earth land on Venus. But interstellar panspermia suggests life drifts between stars. The object, Oumuamua, was the first interstellar visitor we saw. It was weird, flat, accelerating, artificial, or a shard of a destroyed planet. If it carried dormant spores, then life is a cosmic dust that settles on every wet rock. The discovery at the end of space is that we are not special. We are just one colony in a galaxy-wide infestation of biology. But if biology is common, consciousness might be rare. The bicameral mind, the evolution of self-awareness, is it a fluke? Or is it the universe's way of observing itself? The participatory anthropic principle says the universe must generate observers to exist. We are the eyes of the cosmos. If we close our eyes, does the universe vanish? It sounds like philosophy, but quantum mechanics makes it a physical question. The wave function collapses upon observation. We are the collapse engine. The end of space is defined by the limit of our vision. We create the horizon by looking. James Webb has looked at the TRAPPIST-1 system. 7 Earth-sized planets packed tight around a red dwarf. It looks like a perfect place for life. But red dwarfs are violent. They flare. They strip atmospheres. Webb found that the inner planets are likely bare rocks. The Goldilocks zone is not enough. You need a magnetic field. You need a gentle star. You need a moon to stabilize the tilt. The list of requirements for long-term survival is growing. The discovery at the end of space is that the universe is littered with failed Earths, dead worlds that almost made it. The cosmic distance ladder is how we measure the universe. Parallax, Cepheids, supernovae. Each rung depends on the one below it. If one rung is broken, the whole ladder falls. The Hubble tension suggests the ladder is broken. We are trying to measure the size of the room while the walls are moving. We are using rubber rulers. The crisis is a polite way of saying we have lost our bearings. We don't know how big the universe is or how old it is, with the certainty we once claimed. We are navigating the ocean of night with a broken compass. But in the breakdown of the old models, new possibilities emerge. Dark fluid theories, torsion physics, superfluid vacuum. The failure of the standard model is the birth pangs of the next revolution. Physics is not dead. It is molting. We are shedding the skin of the 20th century. The discovery at the end of space is painful because it destroys our certainty, but it is necessary. We cannot stay in the crib forever. The universe is forcing us to grow up and accept a reality that is weirder, darker, and more complex than our simple equations can handle. We have detected gravitational waves, ripples in space-time from colliding black holes. LIGO hears the chirps of space-time vibrating. We have opened a new sense. We are no longer just looking. We are listening to the fabric of reality ringing like a bell. And what we hear is violence. Black holes smashing into each other, shaking the universe. The end of space is noisy. It is a cacophony of collisions. We are tuning in to the symphony of destruction that builds the cosmos. The Penrose process allows energy to be extracted from a spinning black hole. A sufficiently advanced civilization could build a city around a black hole and live off its rotation. This is the ultimate renewable energy, but it is living on the edge of the abyss. If you slip, you are gone. Is this the fate of all high-tech civilizations? Do they migrate to the black holes? This would explain why we don't see them. They are huddled around the campfires of the event horizons, ignoring the cold desert of the rest of the galaxy. The concept of vacuum energy suggests that empty space has mass. This is the dark energy, but the calculation from quantum field theory predicts a value 120 orders of magnitude larger than what we observe. This is the vacuum catastrophe, the worst prediction in the history of physics. Why isn't the vacuum ripping us apart instantly? Something is canceling it out. A fine-tuning of 120 decimal places. It is suspicious. It suggests a balancing act that we don't understand. The discovery at the end of space is that the floor we stand on is rigged with explosives that have somehow failed to detonate. The great attractor pulls us, but the universe expands. It is a tug of war, gravity versus dark energy. Currently, dark energy is winning. The universe will end in a whimper, not a bang. But what if dark energy is dynamic? Quintessence, a field that changes over time. If it weakens, gravity could win again. The universe could recollapse. The discovery at the end of space is that the future is not written. It depends on the behavior of a ghost field we cannot see or touch. We are passengers on a bus where the driver is invisible and the brakes might be cut. James Webb has peered into the Orion Bar, a region of intense radiation and star formation. It is seeing the chemistry of creation. Carbon molecules, PAHs, the building blocks of us. We are seeing our own chemical history, written in the smoke of the nebula. The discovery at the end of space is a mirror. We look out, and we see the ingredients of ourselves. We are not separate from the universe. We are the universe waking up and looking at itself. The horror of the scale is matched by the intimacy of the connection. We are stardust contemplating the star. The cosmic fog of the early universe was thick. Light couldn't travel. Then came the epoch of reionization. The fog cleared. But what if it comes back? If the universe cools enough, could phase transitions render space opaque again? The end of space might be a return to the fog, a slow dimming until the transparency of the vacuum fails. We take the clarity of space for granted, but transparency is a physical state, and states can change. The view we have is a privilege, not a right. The local void we inhabit is growing. It pushes the local sheet of galaxies away. We are evacuating the bad neighborhood of the cosmos. We are moving toward the concentrations of matter. But the matter is clumping. The voids are growing. The universe is segregating. The rich get richer in gravity, and the poor get poorer. The discovery at the end of space is cosmic gentrification. The vast majority of the universe is becoming a wasteland, while the remaining matter huddles in tight, gravitationally bound fortresses against the dark. As we chart the Laniakea supercluster, we see our watershed, but beyond it are the Perseus-Pisces supercluster and the Shapley concentration. These are the titans of our corner of the universe. They are the landmarks in the dark. But the space between them is stretching. They are receding. The map of the universe is expanding faster than we can explore it. We are like explorers on a continent that is inflating. The mountains are moving away from us. The discovery at the end of space is that we can never map the whole thing. The territory creates itself faster than the cartographer can draw. The dipole repeller is a void that pushes. It sounds paradoxical. How can nothing push? It pushes by absence. The lack of gravity there makes the gravity everywhere else feel like a pull. It is a ghost force. It reminds us that nothing matters. The empty spaces shape the universe just as much as the full ones. The end of space is defined by the emptiness. The silence defines the sound. We must respect the void, for it is the majority shareholder of reality. The bullet cluster proved dark matter is real. But theories like self-interacting dark matter suggest it has its own complex life. Dark atoms, dark chemistry, dark light. A dark sector of physics. There could be a shadow civilization in this room right now, made of dark matter, passing through us, unaware of us, as we are unaware of them. Two realities sharing the same space, passing like ships in the night. The discovery at the end of space is that we are haunting each other. The great filter might be stability. Earth has been lucky. Jupiter shields us. The moon stabilizes us. The sun is calm. This combination is rare. The rare Earth hypothesis is gaining ground. If we are rare, then the universe is mostly dead rocks. We are a flickering candle in a windy cave. The discovery at the end of space is the wind. We are protecting this flame against a cosmos that is indifferent to whether it burns or dies. The planetary nebula is the fate of the sun. It will shed its layers, creating a beautiful jewel of gas. But the Earth will be gone by then, swallowed or scorched. The beauty of the nebula is a funeral rite. The universe creates art from death. The end of space is filled with these monuments. The Ring Nebula, the Helix Nebula, they are the tombstones of stars. We find them beautiful because we are far away. Up close, they are catastrophic infernos of radiation. Distance turns tragedy into beauty. The Oort cloud surrounds us, a shell of icy debris. It is the limit of the sun's dominance. Beyond it lies interstellar space. We have sent Voyager 1 and 2 into that dark. They are our first ambassadors to the void. They will drift for billions of years. Long after Earth is dust, Voyager will still carry the golden record. A message in a bottle thrown into the biggest ocean of all. The discovery at the end of space is that we tried to say, we were here, even if no one was listening. Rogue black holes wander the galaxy. We found one recently, only 5,000 light-years away. But there are millions more. They are invisible landmines. If one comes near, it doesn't need to hit us. Its gravity would eject the planets. It would turn the solar system into a chaotic billiard table. We rely on the emptiness of space for safety. But space is getting crowded with debris. The end of space is not empty. It is full of invisible dangers. The cosmic ray flux increases as we move through the galactic arms. We are entering a denser region of the galaxy, more radiation, more risk. The galactic habitable zone is a thin ring. Too close to the center, radiation kills you. Too far out, not enough metals. We are in the sweet spot. But the sweet spot moves. The discovery at the end of space is that home is a moving target. We have to keep up, or we perish. The end of space is also a journey into the quantum realm, the Planck length. Below this size, geometry breaks down. Space becomes foam. If we zoom in enough, the smooth fabric tears. We are floating on a sea of quantum bubbles. The stability of the macroscopic world is an emergent property of microscopic chaos. The discovery is that the foundation is shaky. Reality is pixelated, and the pixels are jittering. James Webb has shown us polycyclic aromatic hydrocarbons in the early universe. Smoke? The universe was smoky. It smells like burnt toast and raspberries, the smell of ethyl formate. The sensory experience of the cosmos is strange. The discovery at the end of space is not just visual, it is chemical. The universe has a smell, a taste. It is a physical place, not an abstract concept, and it is toxic to us. We are in a hostile environment, protected by a thin bubble of air. The great oxidation event on Earth killed almost everything. Oxygen was a poison to early life. We are the descendants of the survivors who learned to breathe the poison. Planetary change is catastrophic. The end of space teaches us that adaptation is the only survival strategy. The universe changes, and if you don't change with it, you become a fossil. The anomalies we see are the universe changing gears. We must adapt our physics, or we will be left behind. The black hole information paradox suggests that information might be stored on the surface of the event horizon. The universe might be a hologram. If so, the discovery at the end of space is that we are 2D creatures experiencing a 3D illusion. The depth of space is a trick of the light. We are flatland, dreaming of up. This would explain why gravity is so weird. It is leaking from the 2D surface into the 3D projection. As we look at the cosmic dawn, we see the first light, but before that, the Dark Ages, millions of years of absolute black. The universe was a cold, dark room. Then, gravity ignited the gas. The lights flickered on. We are living in the era of starlight, but it is temporary. The Dark Ages will return. The end of space is the return of the dark. We must cherish the light while it lasts, for it is the exception, not the rule. The James Webb Space Telescope has opened the door. We have stepped through. There is no going back to the comfortable small universe of the past. The discovery at the end of space is here. It is big, it is broken, it is accelerating, and it is mysterious. We are small, but we are the ones holding the telescope. We are the universe trying to understand itself before the lights go out. And that effort, that desperate need to know, is the most powerful force in the cosmos. The most chilling realization that emerges from the study of the end of space is that the stability of our universe may be nothing more than a temporary illusion, a fragile state of affairs that could end at any moment without warning. We rely on the constancy of the laws of physics, believing that the ground beneath our feet and the atoms in our bodies are permanent fixtures of reality. But the discovery of the Higgs boson at the Large Hadron Collider introduced a terrifying variable into our understanding of existence: the concept of metastable vacuum. Calculations based on the mass of the Higgs particle and the top quark suggest that our universe is not resting in the lowest possible energy state, but is instead perched on a precarious ledge known as a "false vacuum." We are like a ball resting in a shallow depression on a mountainside, mistakenly believing we are at the bottom of the valley. If a sufficiently violent quantum event were to nudge the fabric of space-time just right, or if the energy levels were to shift spontaneously through quantum tunneling, the universe could tumble into a true vacuum state. This transition would release a bubble of destruction that expands at the speed of light, rewriting the fundamental laws of physics, altering the constants of nature, and incinerating all matter instantaneously. The discovery at the end of space might simply be the nucleation point where this collapse has already begun, a wall of non-existence rushing toward us that we will never see until it is too late. This potential for vacuum decay transforms our understanding of the cosmos from a stable arena of life into a ticking time bomb where the timer is hidden from view. If a vacuum decay bubble has formed anywhere in the observable universe, or even beyond the horizon we can see, it is already on its way. Because the bubble expands at the speed of light, no warning signal can ever precede it. We would simply cease to exist in one instant, and the laws of chemistry that hold our biology together would fail in the next. The horror of this scenario lies in its absolute finality and its unpredictability. It renders all our long-term plans, all our hopes for galactic colonization, and all our anxieties about the future completely moot. We are building sandcastles on a beach where the tide is not just rising, but is capable of dissolving the sand itself. The silence of the universe might be the silence of a graveyard where other universes have already popped like soap bubbles, leaving no trace of the civilizations that once thrived within them. We are walking through a minefield where the mines are made of the fundamental instability of reality itself, hoping against the odds that the ground holds for just one more day. While vacuum decay threatens us with instant annihilation, the Big Rip offers a slower, more agonizing torture that we can watch unfold in real time. The discovery that the expansion of the universe is accelerating implies the presence of dark energy. But the specific nature of this energy remains the most critical unknown in science. If dark energy is phantom energy, a form of energy that grows stronger as the universe expands, then it will eventually overwhelm every other force in the cosmos. The timeline of the Big Rip is a countdown to total disintegration. First, the phantom energy will tear apart the giant clusters of galaxies, isolating the Milky Way in a universe of darkness. Then, it will rip the galaxies themselves apart, unbinding stars from their orbits and flinging them into the void. As the energy density climbs to infinity, it will invade solar systems, tearing planets away from their stars. In the final moments, the phantom force will become strong enough to overcome the electromagnetic force, ripping mountains from the Earth, then tearing molecules apart, and finally shredding the atoms themselves. The end of space in this scenario is not a place, but a moment in time where the fabric of reality is torn into shreds so fine that nothing, not even information, can survive. Even if we escape the violence of the Big Rip and the unpredictability of vacuum decay, we are still marching toward the heat death, a fate of slow, cold suffocation that is thermodynamically inevitable. The discovery at the end of space confirms that the universe is a closed system with a finite amount of usable energy, and we are burning through it at an alarming rate. Entropy, the measure of disorder, must always increase. This means that every star that burns, every planet that spins, and every thought you have is contributing to the irreversible degradation of the universe. We are slowly approaching a state of maximum entropy, where all energy is evenly distributed, all temperature gradients are smoothed out, and no work can ever be performed again. The universe will become a bath of low-energy photons, a dark, frozen soup where nothing happens forever. This is the ultimate existential horror. Not that we die, but that the universe itself dies, rendering everything that ever happened within it meaningless. The pyramids, the symphonies, the wars, and the discoveries will all be erased in a uniform equilibrium of absolute zero. We are fighting a war against the second law of thermodynamics, and it is a war we are mathematically destined to lose. In the face of this thermodynamic inevitability, the Boltzmann brain paradox returns to haunt us with renewed vigor. If the universe lasts for an eternity in a state of near-empty chaos, random quantum fluctuations will eventually produce ordered structures by sheer chance. It is infinitely more likely for a single conscious brain to hallucinate its existence for a fleeting second than for an entire universe to evolve nearly 14 billion years of consistent history. This leads to the terrifying conclusion that you might be the only thing that exists, a momentary flicker of consciousness in the deep future of a dying universe, dreaming of a past that never happened. The memories you have of childhood, the history you read in books, and the stars you see in the sky could all be false data generated by a random assembly of atoms in the void. The discovery at the end of space might be the realization that space as we know it is a hallucination, and the reality is a cold, chaotic timelessness where reason does not apply. We cling to the idea of the observer as a stable entity, but physics suggests the observer might be the most transient glitch of all. Yet, we persist in searching for physical truths, and the James Webb Space Telescope has handed us a puzzle piece that doesn't fit the box: the impossible early galaxies. These massive, luminous structures found at redshifts that correspond to the dawn of time challenge our standard model of hierarchical formation. They suggest that the universe organized itself with a speed and efficiency that defies the slow, clumsy grasp of gravity as we understand it. This early onset of complexity implies that there is a missing ingredient in our cosmological recipe, a catalyst that accelerated the birth of the cosmos. Could it be primordial black holes acting as seeds? Or is it self-interacting dark matter that formed complex dark structures long before baryonic matter could cool down? If there is a dark structure to the universe that formed first, then the galaxies we see are merely the bioluminescent moss growing on the submerged hull of a much larger invisible ship. We are studying the glowing mold while ignoring the leviathan beneath it. The discovery at the end of space is that the visible universe is a thin veneer over a dark, complex reality that has been hiding from us since the beginning. This hidden reality might be composed of dark stars, hypothetical objects powered by the annihilation of dark matter rather than nuclear fusion. These giants, millions of times the mass of the sun and cooler than a campfire, could have dominated the early universe. They would appear as bright infrared sources, exactly what James Webb is hunting for. If dark stars existed, they would solve the mystery of how supermassive black holes form so quickly. When a dark star runs out of dark matter fuel, it collapses instantly into a black hole of millions of solar masses. This means the monsters lurking at the centers of galaxies today, including Sagittarius A and our own Milky Way, are the corpses of these primordial giants. We are orbiting the gravestone of a star that burned with invisible fuel at the dawn of time. The end of space reveals that the foundations of our galaxy are built on the remnants of a physics we can no longer see, a dark era of history that laid the groundwork for the world of light we inhabit. The mystery deepens when we look at the cosmic microwave background and see the axis of evil, a strange alignment of hot and cold spots that lines up with the plane of our solar system. For years, scientists dismissed this as a statistical fluke or a calibration error. But as the data improves, the anomaly persists. Why would the largest structures in the universe be aligned with our tiny, insignificant rock? This leads to the uncomfortable holographic principle, which suggests that the universe we perceive as three-dimensional is actually a projection from a two-dimensional surface at the cosmic horizon. If we are a hologram, the alignment might be an artifact of the projection mechanism, a glitch in the rendering code centered on the observer. The discovery at the end of space could be the screen on which our reality is played out. It forces us to ask if we are players in a game or merely the pixels on the display. The vastness of space might be an optical illusion generated by the information density of the boundary, making the end of space the only place where true reality actually exists. If we accept the holographic principle, then black holes become the most important objects in the universe because they are the ultimate hard drives. The information of everything that falls into a black hole is encoded on its event horizon. This resolves the paradox of information loss but creates a strange duality. An astronaut falling into a black hole would die, but their information would be plastered on the surface forever. The universe might be a collection of these information surfaces. The discovery at the end of space suggests that the physical matter we value, the gold, the water, the flesh, is irrelevant. The only currency the universe cares about is information. Entropy is the erasure of information, and gravity is the concentration of it. We are caught in a battle between the forces that want to scatter our data into noise and the forces that want to compress it into a singularity. Our lives are a brief struggle to maintain coherence in a universe that wants to scramble the signal. Let us look outward to the great attractor again, the gravitational anomaly pulling us and thousands of other galaxies toward it. We have identified it as the Laniakea supercluster, but even Laniakea is moving. It is being pulled toward the Shapley concentration, which in turn is being pulled toward something even larger. This infinite regression of bigger fish suggests that there is no end to the structure. We are part of a river that flows into an ocean we cannot see. The dark flow carries us toward a region beyond the observable horizon, a part of the universe that is causally disconnected from us yet still exerts a gravitational influence. This is the ghost gravity phenomenon. We are feeling the tug of mass that is technically in another universe, separated from us by the speed of light limit. We are being reeled in by a fisherman who is standing on a shore we can never reach. And the discovery at the end of space is the realization that the line is unbreakable. The implications of cosmic inflation are equally terrifying. Inflation theory posits that the universe expanded exponentially in the first fraction of a second, smoothing out the cosmos. But inflation might be eternal. In this model, the expansion stops in some places to form bubble universes, like ours, but continues forever in the space between them. This creates a fractal multiverse of infinite isolated pockets. If this is true, then everything that is physically possible is happening somewhere. There are infinite versions of you, infinite variations of Earth, and infinite dead worlds. It destroys the concept of uniqueness. The discovery at the end of space is that we are not special. We are just one iteration of a repetitive code. And worse, these bubbles can collide. If another bubble universe were to crash into ours, the domain wall would sweep across the sky at the speed of light, erasing our physics and replacing it with alien laws. We would be formatted like a hard drive. The Fermi paradox screams at us from the void. With all these galaxies, all these ancient stars, and all these ingredients for life, the silence is deafening. The discovery at the end of space suggests a great filter lies either behind us or ahead of us. If it is behind us, we have survived a gauntlet that kills almost everyone. If it is ahead of us, we are walking toward a cliff edge that has claimed every other civilization. The nature of the filter might be technological. Perhaps all civilizations inevitably invent a technology that destroys them, be it AI, nanotechnology, or antimatter. Or the filter might be cosmological. Perhaps the universe periodically sterilizes itself with gamma-ray bursts, and we are simply in a lucky lull. The silence suggests that intelligence is a fleeting spark in a dark room, and we are currently the only ones holding a match. Or perhaps the zoo hypothesis is correct, and the discovery at the end of space is the fence. If advanced civilizations exist, they might be adhering to a prime directive of non-interference, watching us like bacteria in a petri dish. But a more sinister variation is the dark forest theory. The universe is a dark forest full of silent hunters, and any civilization that makes noise gets eliminated. We have been broadcasting our location with radio waves for a century. We are the noisy cricket in a forest of predators. If the silence is a survival strategy, then our attempts to communicate are suicidal. The end of space is not empty. It is full of eyes that are watching and waiting for us to make a mistake. The discovery isn't that we are alone, it's that we are being hunted by something we cannot see. The sheer scale of the Boots void forces us to confront the unevenness of creation. This region of space, 330 million light-years across, contains only a few dozen galaxies when it should contain thousands. It is a perfect sphere of nothingness. How does a hole this big form? Some theorists suggest it is the aftermath of a Type 3 civilization expanding and harvesting every star, encasing them in Dyson spheres until the region goes dark. If this is true, the voids aren't empty. They are full of silent, invisible empires. We look at the dark patches of the sky and see nothing, but we might be looking at the sprawling mega-cities of gods who have moved beyond the need for light. The discovery at the end of space is that the darkness is artificial, a curtain drawn by beings who do not wish to be disturbed. As we analyze the cosmic neutrino background, we are looking for the oldest message in the universe. Neutrinos pass through matter like ghosts. They can travel from the Big Bang to us without being stopped. If we could decode this background, we might see the universe as it was 1 second old. Some physicists speculate that the neutrino background might contain fossils of the physics that existed before the Big Bang. We are swimming in a sea of ancient particles that carry the secrets of our origin, but we are too deaf to hear them. The discovery at the end of space is right here in this room, passing through your body by the trillions every second, a ghost stream of information that connects us to the beginning of time. We are immersed in the history we are so desperate to find. The lithium problem remains a thorn in the side of the Big Bang model. We can account for the hydrogen and helium, but the lithium is missing. This discrepancy suggests that our understanding of the first few minutes of the universe is flawed. Did the lithium decay? Was it processed by an unknown generation of stars? Or did new physics operate in the early universe, altering the nuclear reaction rates? If we cannot balance the books on the first elements, we cannot trust our accounting of the universe's history. The end of space hides the receipts of creation. The missing lithium is a breadcrumb trail leading to a process we have not yet discovered. A secret door in the basement of physics that might explain why we are here at all. The concept of time itself begins to break down at the cosmic scale. In general relativity, time is relative. It moves slower near massive bodies. At the event horizon of a black hole, time stops. At the photon sphere, light orbits forever. But what about the end of time? If the universe expands forever and reaches maximum entropy, time loses its meaning because there are no events to mark its passage. This is the timeless universe scenario. The discovery at the end of space is that time is a feature of complexity, not a fundamental constant. When complexity dies, time dies with it. We are living in the era of time, a brief island of duration in an ocean of timeless eternity. The clock is ticking only because there is still energy to wind it. Quantum entanglement suggests that space might be an emergent property of quantum connections. The ER equals EPR conjecture proposes that wormholes, Einstein-Rosen bridges, and entanglement, Einstein-Podolsky-Rosen pairs, are the same thing. If this is true, the fabric of space is stitched together by quantum threads. If you cut the entanglement, space falls apart. This leads to the idea that the expansion of the universe is actually the breaking of entanglement entropy. We are being ripped apart at the quantum level. The discovery at the end of space is that the distance between galaxies is growing because the quantum glue is drying out and snapping. We are drifting apart because the universe is forgetting how to be a single object. The crisis in cosmology is not just about numbers. It is about the narrative of human significance. We built the Standard Model to make sense of our home. It was a story of order, evolution, and predictability. But the new data from James Webb tells a story of chaos, anomaly, and impending doom. The end of space is the shattering of our comfort zone. We are realizing that the universe is not a clockwork mechanism built for us to understand, but a wild, untamed beast that does not care if we comprehend it. The anomalies, the dark flow, the Hubble tension, the impossible galaxies, are the growls of the beast. We are small, frightened mammals trying to categorize the storm. Yet in this terror, there is a strange beauty. The nebular hypothesis tells us that our solar system formed from the debris of dead stars. We are the afterlife of a previous generation of suns. The discovery at the end of space confirms that recycling is the fundamental law of the cosmos. Nothing is wasted, it is just transformed. The atoms in your eyes were once inside a volcano on a primordial Earth, and before that, inside the heart of a dying giant. We are the universe's way of remembering itself. Even if the universe ends in heat death, the complexity we have achieved, the art, the science, the love, was a victory against the void. We are the fleeting triumph of order over chaos. As we look to the future, the Andromeda collision looms large. It is the next major event in our local history. In 4 billion years, the night sky will be ablaze with the merger of 2 trillion stars. It will be a spectacle of cosmic fireworks that no human will likely survive to see. But the discovery at the end of space tells us that this violence is creative. The merger will spark a new era of star formation. The Milky Way galaxy will be a reborn giant, a fortress of light that will persist long after the other galaxies have receded over the horizon. We are moving into a future that is violent but vibrant. The end of the Milky Way is the beginning of something new. But what of the proton decay? If protons are unstable, then even Milky Way will eventually dissolve. The discovery at the end of space is the realization that matter is ephemeral. We are made of light, trapped in a standing wave, and eventually, the wave will collapse. The material world is a temporary phase of the universe's evolution. We are transient disturbances in the field. This realization strips away the illusion of permanence and leaves us with the raw, naked truth. We are energy, temporarily bound, destined to be free again. The end of space is the liberation of light from the prison of matter. The cosmic distance ladder is broken, but we are building a new one with gravitational waves. These ripples in space-time pass through everything unhindered. They are the new sound of the universe. We are listening to the collisions of black holes, the mergers of neutron stars. We are hearing the heartbeat of the cosmos. The discovery at the end of space is that the universe is loud. It is screaming with gravitational energy. We were deaf for millions of years, and now, suddenly, we can hear the thunder. This new sense will reveal secrets that light could never show us, the dark collisions that shape the unseen history of the universe. We are also hunting for primordial gravitational waves from the Big Bang itself. If we find them imprinted in the polarization of the cosmic microwave background, we will have seen the smoking gun of inflation. We will have looked back to 10 to the power of minus 35 seconds after the beginning. We are trying to see the moment of conception. The discovery at the end of space is the fingerprint of the Big Bang. It is the ultimate archaeological dig. We are brushing away the dust of 13.8 billion years to find the seed from which everything grew. The Dark Ages ended when the first stars ignited, but they will return. The degenerate era awaits us, a universe of white dwarfs and neutron stars, then the black hole era, then the dark era. The timeline is long, and we are at the very beginning. The discovery at the end of space is that we are the primitives. We are the early ancients that future civilizations, if they exist, will wonder about. We are the ones who lived in the glory days of the universe, when the sky was full of stars. We are the privileged few who got to see the cosmos in its prime. The James Webb Space Telescope is our time machine. It allows us to visit the past, but it also shows us the future. By studying old, dead galaxies, we see our own fate. By studying young, chaotic galaxies, we see our origins. The discovery at the end of space is a mirror of time. We are looking at a gallery of our own life cycle. The universe is a fractal of birth and death, repeating on every scale. From the life of a mayfly to the life of a galaxy, the pattern is the same: emergence, complexity, decay, and dissolution. The great attractor pulls us, but we are also pushing back. We are sending probes, signals, and ideas into the void. We are the universe's attempt to understand itself. The discovery at the end of space is not just a physical fact. It is a cognitive event. The universe has woken up in us. We are the eyes of the chaos. Even if we are doomed, even if the vacuum decays, the fact that we figured it out is a victory. We stared into the abyss, and we mapped it. The Hubble tension might be the crack that lets the light in. In the history of science, every time there was a tiny discrepancy, it led to a revolution. The perihelion of Mercury led to relativity. The blackbody radiation problem led to quantum mechanics. The Hubble tension will lead to something new. A new physics. A new understanding of reality. The discovery at the end of space is the birth pangs of the next paradigm. We are confused because we are about to learn something profound. The confusion is the precursor to the breakthrough. The cold spot in the CMB might be a portal, a bruise from another universe. If the multiverse is real, then the end of space is just a border crossing. Death in this universe might be birth in another. The energy has to go somewhere. The discovery implies that our reality is porous. We are not sealed in a jar. We are in a sieve. Matter and energy and gravity might be flowing between bubbles in the cosmic foam. We are part of a larger ecology of universes. The dipole repeller pushes us away from the void. It feels like a rejection. The universe is expelling us from the empty places. We are being herded. Is there a shepherd, or is it just the blind mechanics of density? The discovery at the end of space makes us feel small, pushed and pulled by forces we cannot control. We are driftwood in a gale, but driftwood can still travel. We are on a journey to the Great Attractor, a voyage that will take billions of years. We are cosmic travelers, whether we like it or not. The cosmic web is snapping. The connections are breaking. But in the clusters, gravity holds firm. We are moving into an era of islands. The discovery at the end of space is a warning to hold on to our neighbors. The Andromeda Galaxy is our lifeboat. We need to merge to survive the lonely era. The future is local. The grand scale is dying, but the local scale is intensifying. We are consolidating our assets against the coming winter. The dark flow remains the biggest question mark. Where are we going? To a megastructure beyond the horizon? To a knot in the space-time manifold? To the drain of the universe? The discovery is that we have a destiny. We are not drifting aimlessly, we are being pulled. There is a destination. We will never reach it in our lifetimes, or the lifetime of the sun, but the atoms of our galaxy will eventually arrive. What awaits them? A singularity? A crunch? Or a new beginning? The James Webb Space Telescope has done more than take pictures. It has challenged our philosophy. It has shown us that the universe is older, stranger, and more hostile than we dreamed. The discovery at the end of space is the death of anthropocentrism. The universe was not made for us. We are a happy accident in a violent machine. But accidents can be beautiful. We are the glitch that learned to love the machine. The end of space is also the end of ignorance. We can no longer pretend the sky is static. We know the monsters are there. We know the vacuum is unstable. We know the phantom energy is rising. This knowledge is a burden, but it is also a weapon. It allows us to prepare, to think on long time scales, to become a Type 1, then Type 2 civilization, to engineer our survival. The discovery is a call to action. Grow up or die. The cosmic horizon is receding, but our minds are expanding. We have modeled the Big Bang. We have simulated the heat death. We have mapped the dark matter. We have enclosed the infinite in our equations. The discovery at the end of space is that the human mind can encompass the universe. We are physically small but intellectually infinite. We can hold the big rip in our thoughts and not blink. As we stare into the boot's void, we see the abyss, and the abyss gazes back. It tells us that we are rare, that light is precious, that consciousness is a treasure. The discovery at the end of space creates a new cosmic ethic, the preservation of complexity. In a universe that wants to grind everything to dust, our duty is to build, to remember, to create. We are the resistance. The great silence is not a sign of emptiness. It is a sign of danger. But we are still speaking. We are sending Voyager. We are sending radio waves. We are shouting into the dark. It is an act of bravery or stupidity, but it is human. The discovery at the end of space is that we refuse to be quiet. We will rage against the dying of the light until the very end. The local bubble of gas we sit in is a supernova remnant. We live in a graveyard of stars. But from that graveyard, we built a civilization. The discovery at the end of space is that death brings life. The destruction of the old universe fueled the new one. We are the phoenix rising from the ashes of the Big Bang. The cycle continues. The axis of evil suggests we are central. The Copernican principle says we are not. The tension between these ideas is the tension of our existence. Are we special, or are we nothing? The discovery suggests we are geometrically special but physically insignificant, a paradox. We are the center of the observable universe, but only because we are the ones observing. The center is wherever you stand. The cosmic neutrino background is the ocean we swim in. The dark matter is the wind that pushes us. The dark energy is the current that carries us. We are sailors on a strange sea. The discovery at the end of space is the map of the ocean. It shows the monsters, the storms, and the edge of the world. We are sailing toward the edge, eyes open, engines full. The redshift stretches the light until it is invisible. The future is invisible, but we can calculate it. We have the math. The discovery at the end of space is that math is the language of reality. Even when our eyes fail, our equations see. We have built a second sight. We can see the Big Rip coming billions of years before it arrives. We are prophets of physics. The false vacuum hangs over us like a sword of Damocles. But it has hung there for 13.8 billion years. Maybe it will hang forever. Maybe we are stable enough. The discovery is a risk assessment. We live in a dangerous neighborhood, but we have survived this long. The resilience of the universe is as mysterious as its fragility. We are still here. The heat death is the ultimate peace. No more struggle, no more pain, just eternal silence. Is it a horror or a rest? The discovery at the end of space frames the end as a release. The universe works hard. It burns energy, it fights gravity. Eventually, it deserves to sleep. The big freeze is the cosmic retirement. The James Webb Space Telescope will eventually die. It will run out of fuel. It will drift. But the data it sent back will live forever in our archives. The discovery at the end of space is the legacy of humanity. We looked, we saw, we understood. Even if we are erased, the fact that we knew the universe existed matters. We were the universe's moment of clarity. The dark flow pulls us on. The great attractor waits. The Big Rip threatens. The vacuum decay lurks. The universe is a thriller movie. The discovery is that the plot is thickening. We are in the third act. The stakes are infinite. And we are the audience, watching the screen, waiting for the finale. The end of space is where the map ends. Here be dragons. But we are dragon hunters. We are building the next telescope. The Large Synoptic Survey Telescope. The extremely large telescope. We are not done. The discovery is just the beginning of the next chapter. We will push the horizon back. We will find out what is pulling us. The cosmic mystery is the only thing that matters. Why is there something rather than nothing? Why is the universe intelligible? The discovery at the end of space brings us closer to the why. It strips away the illusions and leaves us with the raw data of existence. It is terrifying, yes, but it is true. And truth is the only thing worth having. We are the children of the Big Bang, grown up and looking at our parents' photos. We see the violence, the chaos, the luck. We see how close we came to not existing. The discovery is a feeling of gratitude. We are the improbable survivors of a cosmic lottery. We have won the jackpot of existence. The end of space is not a wall. It is a question mark. It challenges us to go further, to think bigger, to be braver. The universe is huge, dark, and scary, but we are the spark that lights it up. We are the meaning in the void. As long as we are here, the universe is not empty. The discovery sitting at the end of space will change everything, but it hasn't changed the most important thing. We are here, we are awake, and we are watching. The story of the universe is our story, and we will write it until the very last light goes out.